for joining me on Saturday's fun water supply class. So you're gonna have we're gonna have 4 modules. The first one will be characteristics of water, and then the second one will be tools and appliances of water supply. Third one will be water supply operations, and the fourth one will be just the conclusion. Out of the 4 modules, there will be 4 activities we will have to do. Dr. Miller is going to help me instruct because right now the span of controls for me is over 5, so he's just going to be an instructor to help the span of control. Class has to be at least 4 hours minimum. I'm hoping to be done by 3:30 or maybe 3:45 since we got started late because of the call. We will break for lunch at noon. I did provide lunch, so I do have sandwiches and chips upstairs. And while we're on break, Miller's going to get 20 pulled out and 23 pulled out because one of the skills is using the port things. So let's get that going. So some of the stuff you'll see for the Fire 1 and 2 students, it'll just be a refresher for you because the names and acronyms for some tools are all together, so it's only the easiest place to pull from is the Fire 1 and 2 book. And there has been changes to some names that I'll cover so you guys understand. And then if anybody wants the resources that I pulled all this information off of, just let me know. For the tools and stuff, I use my old edition 5 Vista book. I know we're on 7, but I didn't have access to the 7 book. I just used 5 because all the names are still the same. So, if you don't know who I am, John Chartrand, Battalion Chief, Military Fire. There will be a course registration that I will have you fill out at the end of the class. We will use everybody's got a pen, right, or a pencil? So, so Andrew, Ellen, Robert, Miller, all these are just like the Fire 1 and 2 slides. You have to follow along and fill out answers that are missing, so you guys don't fall asleep in class.
What do you have for you today?
Someone may have a second copy stapled with it. You can just review that, John. And follow along with it too. Here is you'll have skill sheets also. This is the skill sheets to go on with the activities. So you can review them now, or you can review them during breaks. It's gonna remind you of Fire 1 and 2, Andrew. There will be a test at the end of the class, and there'll be a evaluator sheet for me. It don't have a spot for your name, so don't put your name on it. So just fill out the course name, location, my name for the instructor, and we should be fine there. Alright, so moving on to the objectives here. Come on, don't fail me now. You're gonna fail me. Sure. So, excuse me. So, the lesson objectives, which is course objectives, you'll see these split up between the different modules. So they all go in order. So, number one, the student will be able to understand principles of water as an extinguishing agent by the end of class. Two, by the end of class, the student will be able to identify all appliances and tools associated with water supply. Three, from information presented in class and with proper equipment, the student will be able to demonstrate how to set up a connection to a hydrant. Four, information presented in class, the student will be able to differentiate between a forward and reverse lane. Five, given the proper equipment, the students will demonstrate how to properly set up a port tank operations during a practical activity. Six, from information presented in class, the student will be able to determine which type of water supply is needed. And from information presented in class and given a scenario, the student will be able to define the need for water supply. By the end of the class, the student shall be able to develop a water supply pre-plan. So the class is, like I said, it's going to cover some of Fire 1-2 stuff that some people have learned, some people have not. But the water supply is going to talk about how we set water supply here at Hempside. A lot of people do the exact same thing as us, some people don't. So you have daisy chaining, you have forward, reverse lays, split lays, tanker shuttles, tanker relays. We're going to cover all that today. So you'll understand a water supply and how important it is to set up, especially for us. And if you have reviewed the activity skills book, you'll have to create your own water supply pre-plan in module 3, and then we will review them all together and see what people would think and what people would change, just to see how you guys understand setting up water supply. Because I'm sure besides a few of us, majority of everybody will be in a situation where you have to set water supply. As a firefighter, as an officer, it doesn't matter. If you're driving the truck that is set to set water supply, you have to figure out what you're going to do. So, module 1, characteristics of water. And if anybody needs to use the bathroom, if anybody ain't familiar with the firehouse, there's one right there. There's one downstairs in the chief's office. And since John and me are the duty crew, if there's an EMS call, Miller and Ellen's going to take the call. And then if we have a secondary call, I'll just take whoever I need to take with me. And we'll pause the class and then keep moving on. That's still recording, Robert?
Yep.
Yes. Just double check. Alright, so before we start, does anybody looked into how water, the characteristics of water? How water towers work and all that? No? Okay, well, we're going to dig into it. We're going to have some class discussion about stuff. So, like I said, module 1, characteristics of water. You have one objective. The student will be able to understand principles of water as an extinguishing agent by the end of the class. So let's dig into it real fast. So, before you can establish water supply, you got to understand how water works. If you don't understand water, you're not going to set water supply. Some people think, oh, I can connect it to the hydrant, turn it on, and water supply is set. No, that ain't how it works. That's the easiest thing that people do, but if you don't understand, you're not going to get ahead of the fire. Water is mostly frequently used as the extinguishing agent because it is the cheapest. Water can be found almost anywhere in the world. Around here, we have a combination of a pressurized water source with pumps and gravity fed. So if you go around and look at all of our water towers, the one right here at Karen and Holly Hills up on top hill, they actually have 2 pumps that are at the bottom of the tank, but they don't kick on until the water supply system is at a certain level. So right now, if you just turn on the tap, it's just gravity fed water. So, like I said, it is very abundant and inexpensive compared to other types of fire extinguishing mediums. So, like R7 uses, they use foam. Vestas has foam, but they use it in conjunction with water. So, I know Robert's familiar with R7's pumps because he worked over there. Around here, we have buckets of foam that we use for just Class B fires. But we have water is around here is just it's cheap, easy to use. So that's why we use water a lot. Quick thing, if anybody hasn't seen the answers, they are underlined and italicized for you. So to fill out. So if I'm going too fast, let me know. I'll slow down and we'll go back to slides if we need to. So to use as our primary ammunition, you must know some important basics about water. So water freezes at 32 degrees. We're going into winter right now, right? This morning the temperature was 22 degrees. We started having fire. We had fire this morning at the low temperature. It'll probably freeze on us once it starts to get on the ground in the grass. Everybody knows if you look at the grass, the frost is starting to die out the grass because it's freezing. So water supply operations during wintertime is very crucial to understand how water works. Like I said, we'll dig into it here in a little bit. Water boils at 212 degrees. So if you're a pump operator, you need to know to keep your pump cool, or you're going to start overheating your pump and you can burn the pump out or bearings, and it'll be very bad, very expensive. So that's why we have temperature gauges on the pump panel so we can watch the temperature inside the pump. So what's going on with how hot when it boils at 212, so it makes water a good extinguishing agent. So does everybody know how when water goes in to a fire with our combination nozzles, what it's doing? So, well, you're moving heat. So the water absorbs the heat by released by the fire, okay? So our combination nozzles, instead of a straight stream where we need to pierce stuff, it's got a combination that's coming out in small particles of water, all right? So when it goes into where the fire is, that's being converted into steam, which is soaking in or absorbing the heat to the water. So you'll always hear chiefs talk about in those days, St. Louis City, they still do some places, they take the water can in first, with a small fire, they'll put the finger over their fire extinguisher, spray it in there to create the water droplets, and they can put the fire out with just a water can. You're using the particles of the water that's being broken up to absorb heat and release steam, which extinguishes the fire. So energy from the fire is imparted into the water and it changes to steam. Water turned from a liquid state to a vapor state requires a great amount of energy. So that's where the fire comes in to create that energy to change from water to steam. Going along with the weight. Water weighs 8.3 pounds per gallon. So, a fire apparatus has the ability to pump on average up to 1,000 gallons per minute, depending on the water supply. 20s pump, 24s pump, they're rated at 1,500 gallons a minute. Without the water supply, that pump cannot pump 1,500 gallons a minute. You need a water supply system that could give you that. So if you look at a hydrant like the firehouse one here, it can give 750 gallons a minute. Anything over that, you're going to cavitate because you're not getting enough water. So that's where the water supply comes in with when you pull lines and stuff. You need to know how much water you need to supply for water supply. Every minute we are adding 4 tons of water into a structure, and therefore a collapse of the building is a real potential. So if we're given 1,000 gallons a minute, we're in 4 tons into the structure every minute. So, if it don't burn through the floors and stuff like that, and the building's holding the water on like the second story, you're putting more weight on the trusses for collapse. So that's why we had to make the water run down the steps or out through somewhere to get the water off them that load. So water is non-compressible, so that's why it goes along with car engines. So if you get water into your engine or your oil, it gets into the pistons, and when it wants to raise and lower, it can't be compressed. That's why sometimes you can blow an engine or blow shatter your piston, because water cannot be compressed. Alright? So this is the primary reason why you are told to open and close a nozzle, gate valves, hydrants, or any other appliances slowly. Because what we go with is water hammer. So if you close the nozzle fast, if you ever see the hose line jump, you're creating a water hammer inside that line. You can do it with a hydrant. So if you close the hydrant fast, you can actually create a water hammer through the line, and it'll find the weakest point in the water supply line and rupture that line. There's been numerous times that we've done it. I mean, that's why you just open and close water supply slowly. The more you rush, the more issues you're going to have with your water supply. So you want, like I said, water supply is key. It's one of the important factors in extinguishing fires. So flowing water carries a lot of energy and inertia through a hose. Example, you're supplying a 2.5-inch hose line flowing at 200 gallons per minute. You're moving over 1,600 pounds of water every minute. So, now remember, that's pounds, not PSI. Alright? So if you close at 2.5, because you needed the 2.5, it's going to force that 1,600 pounds to come into a sudden stop and then go backwards. You'll, like I said, 1.5 inches or 1 3/4 that you see, you'll see them stop it, it'll jump. Like if you go to Fire 1-2 or see live burns like next week, if you see them shut it down quick, you'll see the hose line jump. And it'll run all the way through the pump and out to the water system. It's actually, if you talk to Chief, when they had the big fire down on 67 at the fireworks store at Long Road, was it? Festus's ladder truck, the old one was there. They shut the ladder down so fast. He was down off of Lake Drafton, like 1,500 feet away. It ran through the ladder, ran through their pump down 5-inch into the 20, and it was so big of a water hammer, it stopped the impeller of the pump and it killed the truck. And then went through the hard suction into the water and created ripples across the water. So we got lucky that it didn't blow the pump, but it did push the packings out of the old pump. So we had to replace the pump packings.
Didn't it blow a toilet out like miles away or something one time too in Winnipeg?
No. So I know that there's a hydrant over on Hematite. It's up on top hill by the cemetery. If you turn that hydrant on, it's like 200 gallons a minute. It's really nothing. But if you turn it on and when you create the water to come out, you'll shut people's water off the houses up on top of the hill. Because the water system, we don't get the best water system. We have an average one, like under average, but at least we have water. So going along with water hammer, so like I said, if you shut the nozzle, the water in the hose is still moving, which then causes a water hammer and has a possibility to cause severe damage or injury. The damage normally breaks into the weakest point of the system: hoses, pumps, main water mains, etc. So going along with PSI, which is pounds per square inch. This term comes from the weight of the water in 1 cubic foot of water, 1 cubic foot of the water. So 1 cubic foot, it's PSI. The law of hydraulics states that the weight of the water 1 foot high will exert a weight of understand that. The 4.34 pounds at its base. It should be covered in the figure 1 of your manual there. Let me pull it up on my thing fast. So the figures that you'll see explains how the water works in the 1 square foot. Okay, so you have 1 cubic foot on that figure 1, which is or vertical, and then you have the 1 square inch column of water 2 feet high, and 1 pound per square inch of the weight pressing down, or 1 psi. So gravity and all that comes in factor with water. And then, so figure 1, if you look at the bottom of your page, on page 3, figure 1 above illustrates the use that using the rule of thumb, formulate the weight of a column of water at its base is half the height in the picture above. A 2 foot high column of water exerts a pressure of 1 pound or 1 psi at its base. So at its base, it's 1 psi. Right here. Going along with the water, so there's 6 principles of fluid pressure. So it is important that we are aware of the 6 principles of fluid pressure before we talk about the different kinds of pressures. So so 1, liquid pressure is exerted in a perpendicular direction to any surface on which it acts. Okay, so it's being pushed out. So say Robert's cup was filled with water. It's going to run perpendicular with the water, so it's pushing weight out on its sides. Okay. 2, at any given point beneath the surface of the liquid, the pressure is the same in all directions, downward, upwards, and sideways. 3, pressure applied to a confined liquid without transmitted in all directions without a reduction in intensity. The pressure of a liquid, this is 4, is an open vessel and is proportional to the depth of the liquid. 5, the pressure of the liquid is an open vessel is proportional to the density of the liquid. And then 6, liquid pressure on the bottom of a vessel is unaffected by the size and shape of the vessel. So if you see figure 2 of your paper, it illustrates on the principles. So that should be on page 4. So this is where the water towers come in play. So what it's talking about is it's always pushing out on its sides and then down, and then so the numbers are all off, but your paperwork should show. So on the middle column, the top circle is 30 psi, and then at the very bottom circle it's 60 psi. All right, so you have a water tower that is 100 foot tall. There is 50 psi at the bottom of that water tower. That's what you're getting on a water tower. That's why some water towers have pumps that kick on to force that pressure up. So usually so figure 2 in the illustration above, number 1 represents the principle 1, where pressure is exerted in a perpendicular. Number 4, which is the middle one, represents principle 4, where the pressure increases as the depth increases. And then the water tower looking one is number 6, which represents the shape and size of the vessel does not matter. So that's why water towers are all different shapes, but with the laws of fluid, it doesn't matter. It's just the pressure and gravity. Going into your different pressures. So the first one is atmospheric pressure. It is the air pressure that is on everything on Earth. So right now you have atmospheric pressure pushing down on everything, every object, person, anything. it's got a pressure. So that pressure is 14.7, and it's pressing against your bodies right now and all other objects. So there's always a 14.7 atmospheric pressure. It is important when it comes to understanding drafting water. Alright, so does everybody understand drafting? How do you draft water? So, are we using a pressurized source or are we using a negative force to bring it up?
Negative force.
We're using negative force. You have to force the water up into the pump, so you're creating a negative force. Robert and Eric, you have straws. When you take a drink of your water or drinks, you're creating a negative force, which is drafting. It's the easiest thing to explain with cups. Getting into pumping, it's a little different, but the easiest way to look at it is drinking out of a straw. You're creating that negative force. You're pulling, not pushing. So pressures less than atmospheric pressure are called a vacuum, also known as ambient pressure. So that's why if you look on the side of the pump panel, some of the two big gauges in the middle, one either says vacuum pressure or intake pressure, and one says discharge pressure. So discharge pressure is what you're forcing. Intake or vacuum is what you're bringing in. Now that gauge will do both. So you're getting a water supply from a hydrant, it's going to regulate because you're getting a pressurized source through the intake. Now if you're drafting, once you get water in, it'll create pressure because water's coming in. The easiest way to lose a draft on a truck is any open air system or any hole that air can be sucked back into the truck. It'll create air in the pump and then it'll drain it back in the truck into the water source that you're drafting out of. So going along with the straws again, if you put a little pinhole in your straws, so I'm sure everybody does it, they take the straw, bang it on the table, get it out of the paper. Sometimes that straw bends and breaks. If you put that in, it's going to suck your flute down to that break. And once you get done the break, it's going to bring air in from the top of your straw instead of drawing the fluid in from the bottom. Because you're letting air in above the drink or fluid. So 14.7 psi on everything. So this should be 14, but it says 4. That should be 14. So there's 14.7 psi from the top, from the sides. So that you always have a 14 psi on or 14.7 psi as your ambient pressure. Head pressure. So head pressure is the height of a supply of water above a discharge opening. Excuse me. Example is an above ground water storage tank. It should be tank, not tin. So head pressure, the water tower creates head pressure. So let's assume we have a 100-foot water tank. We have a pressure gauge at the base of that water tank. We know water exerts a force of a half a pound or half psi for every foot of height, right? The pressure at the bottom of the base would be 50 psi. So half of 100 foot is 50 psi. Okay? Everybody get the fill in blanks for head pressure? Everybody understand head pressure? Okay, just like it's the force of the water tank at the bottom of the base. This is where it comes into water supply and where we hit a hydrant and stuff like that. So your next pressure is static pressure, which is, it means stationary or no movement. The reading at the base, 50 psi is called static pressure because the water is not flowing in the system. So when you go up, has everybody here done hydro testing? No. So we have 3 gauges. Well, we have 3 readings that we have to do. Okay, when you turn on the hydrant, you flush it first to clean out all the junk in the hydrant, so you don't want to clog up your gauges. The first pressure you should get is the static pressure. You turn the hydrant on, you have a cap on it, everything's shut off, but the hydrant's on. So water's gonna come up, hit the gauge, and stop. It's gonna create a pressure on the gauge. Whatever that gauge levels out at and stops, that's your static pressure. Okay, it does not move. That's why we call a lake or a pond static water source, because it's not moving. Okay, that's a static. Or the pour tanks, it's not moving. Water's being dumped in, not moving. Okay. Example, 100-foot water tower. We have it come to the ground, and at the hydrant, it's 50 psi. Okay, figure 4. So this is what I'm talking about. You see the gauge right here? We have a 2.5-inch cap with a gauge, pressure gauge on it that can read up to 160 psi. It's going to give you your static pressure. Now, if you had pumps on here that kicked on, it'd create more pressure because it's creating pressure, pressurized source. But it's going to stop when it gets to the hydrant. Residual pressure, or residual, means what is left over. Pressure on a gauge that is in motion. Your gauge will drop due to flowing water. Reading also known as residual. So that's when you have the gauge, same gauge on, but then you open up your gate valve on the other side. You open it all the way up. Water starts flowing out of the hydrant. It'll drop down, and then it'll level out to give you your residual. The closer the static pressure and the residual pressure together is a better gallons per minute. If you go hydrant testing with us, usually the residual is like 10, and the static pressure is about 106, 120. That means your water or your gallons per minute is low. Like the chief says, the closer to them two numbers together, the better gallons per minute the hydrant or the water tower put out. Am I good with fill in the blank there? All right. So, example of the residual water flowing. 100-foot water tower, hydrant is on. It drops from 50 to 35 psi because the water is flowing. So, module 1 conclusion. Knowing the characteristics of water will help in setting up water supply. Water freezes at 32 degrees and boils at 212 degrees. The weight of the water is 8.3 pounds per gallon. Moving water has a lot of inertia and energy. Water is the main arsenal for firefighting supply. Why? Because it absorbs heat. It takes the BTUs out of the fire. Water has 6 fluid pressure principles. Water has an atmospheric, head, static, and residual pressures. There is 14.7 psi of atmospheric pressure at any given time. Knowing the way water works will save you time and effort in water supply operations. So we'll take a quick break. Does anybody have questions about the characteristics of water? How it works, how it moves.
So,
All right, so we'll take a quick break, and then we'll come back and start telling.
It's freezing down.
All right, welcome back.
where we going?
Here, all right, so module 2 covers tools and appliances for water supply. So this will cover almost every piece of equipment that will be used on the fire scene for water supply. Let's dig in. This is hopefully the fun chapter with the activities. So the objective of this module is by the end of class, the student will be able to identify all appliances and tools associated with water supply. Alright, so tools and appliances. They are grouped into 2 categories. 1, hose appliances, and 2, hose tools. The recognition of the correct tools or appliances will save time during a live fire incident. Various devices used with the fire hose other than hose couplings and nozzles. So these are devices used with fire hose other than couplings and nozzles, okay? The easiest way to remember the difference between them is appliances have water flowing through them. Tools do not, okay? So if water goes through that object, it's an appliance. If it's water cannot flow through it, it's a tool. Hose appliances. Any piece of hardware used to deliver water in conjunction with fire hose. Hose appliances range from valves, fittings, intake devices, and valve devices. Valves, they control the flow of water at a hydrant, in hose lines, or at the pumper. You have multiple types of valves. We use every single one here. Okay, we have a ball valve that's used in the pump discharge or gated Ys. So, as everybody's seen, the gated Y that we have on the trucks or upstairs in the engineer's compartment, it's got the handles that twist. It's got a ball in there that when it's closed, it's shut. There's no opening, and when it opens up, you have a hole the size of the diameter of that, like the nozzle. And so you got a ball in there. You open and close your bail. It's got an 1.5 inch or 1 3/4 size ball opening in it. Gate valves, they control the flow of water at the hydrant. So this is what we use when we're at the hydrant for connecting on a hydrant. So this will save you time during water supply. It'll probably be covered later on in the chapter, but the gate valve goes on the hydrant. You can open your hydrant, let the water flow out so you can flush it. Then instead of turning the hydrant back off to connect your hoses, you can just close the gate valve, hook your hose onto it, and away you go. Usually gate valves are only 2.5 inch. They just go on a 2.5 inch male on hydrant. I have not seen a 4 inch one for the steamer, so if they do, it'd be kind of badass, but I'm sure it'd be a lot of pressure behind the steamer cap because of the force of the water. Butterfly valves, they're used on large pump intakes. They are flat baffle and turn 90 degrees. New ones operate on electric. So if you look at 6220 and 6224, the intakes, the big intakes, the black ones, they have butterfly valves behind the pump panel. They are operated by the switches on the pump panel itself. It controls the motor. It opens, so it's closed, and then it goes like this. It allows water to flow past it. Before, on the old trucks, you actually had to crank it, and if you had pressure behind it, you can ask Miller on the 06224. If you had the butterfly valve, it was hard to open with the pressure from the hydrant. Oh yeah, you remember. Even the gate valve on the passenger side of 24 was hard to open. Clapper valves, they use in Siamese applications, prevents water from coming out unused ports. Flat discs on hinges at the top or sides. This is on the back of 6220. This is what we use for tankers to pump into us. It allows one truck to pump in while the other 2 trucks are hooking up. The pump operator knows to tell the tankers to pump at 50 psi, because once you get water flowing through that system, if one truck's pumping 100 and the other 2 are trying to pump 50, that 100's going to close the 2 ports off. All right, but there's times when we, as pump operators, we tell the biggest tanker to go up so they can dump the water faster than the small tankers. We'll discuss that issue in the tanker relay because it's all time. We should be like a page 2. Andrew, maybe 2. We're on page 11. After we get done with the break, I'll go back and get. You probably can answer all the questions or stuff if you wanted to. So there's the ball valve, gate valve, butterfly valve, and the clapper valve.
The answer to those questions starts on 9.
Okay, page 9 starts on, and then we're on page 11, you said?
Yeah.
On your page, all the valves are there. Now, there is a couple tools that you'll find out today that are almost like these tools, but they're a backward applications, okay? Great.
I knew I should've left my
We're gonna
name
have calls all day. All right. Ellen, all these start on 9, and then we're on page 11.
Oh, okay.
But we can get them at the end of the class or end of this chapter. So these are the valves. All right. So the top left one here is called the gate valve. That's used on fire hydrants, and usually the majority of time it's used is on 6223 on the back when you're filling tankers. Just leave it on the hydrant. After you fill 23 up, you shut the valve off and just disconnect from the truck, and then away you go. The bottom left is a ball valve, gated wide. It's got handles. There's a ball in here, both sides, 2.5 to 1.5 inches, and open and close. This is called a distributor. This is the backwards of the clapper. So this is the clapper valve, but ours is bigger. It's about the same size as this, but it allows water to go in, and there's the 2 flaps in here to keep the water from coming back out. And then your butterfly valve, there's a valve right there, the butterfly. It goes in line with the valve itself to let water past it. Everybody good on the valves? Valve devices, they can increase or decrease the number of hose lines operating at a fire ground. Valve devices consist of Y, Siamese, and hydrant valves. A Y divides a hose into 2 or more lines. Your most common is a 2.5 inlet to 2.5 inch outlets. The thing to remember with Y is if you're putting more hoses on the ground, you're adding more gallons per minute that you have to put out. Right? 1.5 inches that we flow 125 gallons a minute at the nozzle. So if you add another hose line, that's another 125 to make 250 gallons a minute. If you add a second Y and then want 2 more lines, you're adding another 250 gallons for 500 gallons. So you need to make sure your water supply can supply them hose lines. It comes into a factor again when you're dropping 2.5. If you need big water, you need to make sure the water supply is there to supply that water. Remember, 2.5 supplies 250 gallons a minute. So if you have 2 of them on the ground, you're supplying 500 gallons a minute just off of 2.5. Size of the hose matters with your application. Valve device continued. A Siamese consists of 2 or more lines brought into a single hose line, the opposite of the Y. A Siamese may be equipped with or without a clapper valve. Usually has 2 or 3 female connections into the device and 1 male discharge, and used to provide large quantities of water at lower friction loss. I'll let you guys take a second and write that down because that's a big one. So that's where the clapper comes into play on 20. You have 3 female inlets. You're taking water from all 3 trucks into the 5-inch side of it into the pump to give you more gallons per minute. We use the clapper system here a lot more than hidden hydrants and drafting. It may be quicker to set tankers with the clapper than setting up the 4 tanks or trying to lay line to the hydrant that you need to lay from. Sorry, if I'm ignorant, just checking the time and make sure the computer works.
You're good. I'm old and
I
can't
don't
see.
need to reset and go back and teach this again. I'm sure you guys would be like, Okay, so moving on to the next, a hydrant valve is used when a hose leg is made from the water supply, usually a hydrant. Usually we don't put wide or hydrant valves on trucks at the discharges because we have its own handle that controls that discharge. Like I said, the wide or the hydrant valves you'll see usually being used is the back of 23. There's two of them in the troughs to hook both lines into both sides, both ports, to fill a tanker faster. But that's where you're going to see it used more unless you're going hydrant testing. We use a valve off of 20 so we can check all of our gauges and stuff like we did back in module 1 when I showed you. Allows the supply line to be attached to the hydrant and the hydrant to be charged before the arrival of the pumper. So if you're being told to set set hydrant operations by doing a forward leg, so if you get off truck, if I'm driving the truck and I say hit the hydrant, you're going to pull the 5-inch off. That's got a hydrant valve in it with different fittings. You'll get that all set up, and then you can actually have the hydrant running before you make the connection. Does that make sense? So when we give the sign to charge the line, the hydrant's already running, you just go whoop and open up the hydrant and away the water comes. So water thief allows you to supply multiple hose lines supplied by one LDH, and LDH is large diameter hose. We here at Hematite usually use the distributor when filling tankers at the draft site. So if you are drafting, there we go. When you're drafting, once you get the draft set up, you'll run 5-inch up to where the tankers can reach to, and then you'll take the distributor up at the top, you'll charge that line, and then once you charge it, your job's done. Your job is to sit at the truck, make sure the drafting operations is going smoothly, and no debris coming towards the truck. The tankers that are coming in will control their own valve to their own truck. So they'll fill, they'll hook everything up, turn the valve on, fill their truck, it'll run out the overflow, turn off, they'll disconnect from the truck, and away they go. So then while we're not supplying water to tankers, the deck gun is usually on and spraying water into the lake or whatever you're drafting out of. Usually that's mainly used at draft sites, is the distributor. You can use the distributor on different areas in our district because say 20, the bridge can't hold the truck, so you need to have a truck pull the 5-inch off of the truck. So like say you use Chief's duty ride, you hook onto the 5-inch with his reese hitch, you pull the 5-inch all the way up to the house. You can take the distributor up to the top, they can charge the 5-inch, and then you can set 3 1.5" up there with reducers from 2.5 to 1.5", and supply hose lines that way. You can still control at the scene. It's just ways on fighting fire and knowing what you can and can't do with your hoses. Fittings. They help connect different size hoses and threads. So if you go upstairs, or here in a little bit when I bring them down here, the thread type is called National Standard Thread, which is NST or NH. That's what we use for all of our fittings. So National Hose is what all fire departments, hopefully in Missouri and the United States, use. You go to Herky, they are able to hook their 2.5 or 3-inch up by, or 3-inch, we go 3-inch, by Storz fittings. They have Storz fittings on their 3-inch. They do have fittings to take it from a Storz to a female or a male thread for us. So we don't got Storz fittings on our 3-inch line. They do. Adapters is a fitting for connecting hose with smaller or dissimilar threads with same inside diameter. So I understand adapters. So you have different threads or fittings the same size of hose. The double male or female adapters are probably used more than any other special hose appliance. Why? I'm sure Andrew knows and Ellen probably knows, before 5-inch was created, you had double 3-inch lays in trucks. You had a reverse lay and a forward lay. You'd pull both of them off the truck, put them to the hydrant, and then take off. When you got to the scene, one of them hoses had to be converted to go from the reverse lay to the forward lay. So you would have to have a fitting at the hydrant to connect the male and male ends together, which would be the double female. And then you need a double male at the fire scene to take the female, and connect them together. Does that make sense? If it doesn't, I'll show you when we do the activity. Storage connections are universal for usually LDH, but can be used on similar hose or small hose. Like I said, Herky's got 3-inch that they run storage fittings on. It's kind of cool, but kind of crappy in the long run, because if we go up there, we have to do all the fittings and all that. So these are fittings. These are the double male on the left, double female on the right, and then a male to female in the middle there. So it just helps you connect hoses back and forth depending on what's going on. Sometimes you may have someone mess up and bring you the wrong nozzle or wrong end of the hose, and you need to fix it quick. I don't think if we did a 400-foot run, I don't think we want to take the nozzles back and just fix it on the fly. Take this up there with that, and then put this here. The thing with fittings and appliances and all that is, anytime you add something in on the hose, you are creating friction, which creates friction loss, which creates more pressure that needs to be pushed from the truck to get it to the nozzle. That's why when we pump the trucks on our pump house, say pump the yellow line at 175, the red line at 120. What you're trying to do on the yellow line is you have to have a higher pressure at the pump to have your minimum amount of pressure at the nozzle, because you want to overcome, like I said, the BTUs of the fire. If you're under pressure at the nozzle, you're not going to overcome the fire. So reducers, they are used to extend a large hose line by connecting a smaller one. Commonly found on a pump discharge outlet, and female ends has the larger threads while male end is smaller. That is correct until you meet our chief. He's got a backward thread, 2.5 the male, or 2.5 female to 2.5 male, which is backwards. So if he gets a hold of you to find, that's one of his questions, is find the 2.5 male to 1.5 female, because it's backwards. That's one of his go-to things, and if it ain't, he'll put it somewhere where you have to find it. So these are the reducers. So these are all female to male. So you have 2.5 on the left, and then you have 2.5 to 1.5 inch, and then you have 2.5 to inch, which is forestry liner for us. This, and if anybody was wondering, so there's different kinds of ends to the couplings. You got the pin type lugs, you have lugs, and you have recessed ones. The recessed ones are hose that are drilled into or recessed into the coupling. You really don't see them around anymore, but you still have the pin types and the regular lugs that we have on our hose. That's why if you look at our spanners, it's got a kind of a notch in it to grab onto the lugs. Other fittings include elbows, hose caps, and plugs. Elbows change the direction of flow, hose caps close off the male end, and hose plugs close off the female end. So our master discharges off our pumpers have elbows on it. That's for the 5-inch, so if they're made for, if they were straight off the truck like the 2.5s are, the 5-inch, because of the weight of the water, would come down and kink the hose. That's why it's on an elbow, so the hose can come out and go flat and don't create kinks. The hose caps are mainly for the male end, and on our trucks we have it on the, trying to think here. The pump panel, the discharges on side, them are caps for the male end, and then hose plugs are the female end. So if you look at the back of 24 or the 2.5 inlet on the pump, them are the caps for the female ends. The bottom left inlet that we use to fill the truck when we're back here. Majority of the time, you're going to run into hose plugs on your hydrant connections or your for your fire department connections at high-rise buildings. Them are usually female ends that have plugs in them. Does everybody know how the direction of water flows by looking at the hose? Well, yeah. So, if you're for search and rescue, the easiest thing to remember on the hose is smooth bump bump to the pump. All right, because that's the lugs on the couplings. So smooth end is the female end. Bump bump is the male end. So water always should flow from the pump to the fire, the male to female. All right. So the female should always take the water going towards the fire. Male should always have end is going towards the fire truck. That makes sense? James, that makes sense to you? We do. I will bring it down and let you guys see what I'm talking about. If you ever look at the hose, the male outside threads, that is always going towards fire.
Got it.
Water should be going this way. If you have a male end and a female, water should be going this way. And then back to you. So that's for the sprinkler system, which is standpipe. Them are the male plugs that go on the female side, elbows, and then just the caps. But that's in the source side. But if you go, like I said, up on 20, the caps for the side discharges off the pump, them are their caps. Intake devices. So our suction hose strainers, they are used for drafting operations and to keep debris out from entering the hose and pump. Let me write that down real fast. They are used in a static source, such as ponds and lakes. Back to module 1. A static source does not move. Used with floating strainers or tied to a ladder. So we have a float dock now in 20 that we can hook our strainer to and just push it out onto the water and it'll draft off water. Before we had that, you are supposed to take the barrel strainer or whatever strainer you're using, tie it to a ladder, which is usually the roof ladder, slide it out into the water, make sure you tie the ladder off to the truck in case for some reason it wants to go floating off, and then start drafting. The thing with drafting is, in a static source, once you start drafting, you're going to start pulling objects towards the draft site. Algae, leaves, tree branches, doesn't matter if it's floating on top or in the water, it's going to come towards your pump. A lot of them have strainers, the metal grates where water can flow through them to stop it, but then you get to the side of the truck, there should be a grate inside of the pump itself to stop big objects from going into the propeller of the pump. Sometimes that stuff does not work and you have fish go into your pumps into your nozzles if you're drafting. If the supply pumper is actually drafting off the lake and the fire's right there, you can actually have fish particles come through the nozzle. Sometimes it might clog up the nozzle too, and then you have to shut that line down and put a new nozzle on. If you ever have questions, just ask Chief Pipes about it. He's had a fish head inside of the truck itself on the inlet of the 20 when he was drafting. And any particle that gets in the pump and stops water flow will create friction loss, and then you're not going to get your full gallons per minute. If you're drafting out of a lake, remember, if you're using 20 to 24 and you're coming off the sides, you're drafting 1,500 gallons a minute. So that's how much water you're pulling in at a second or at a minute. If you're drafting off the rear of 20, you're getting about 750. 24, you're getting about 800. So make sure if you have to back down and use the rear, that's remember your gallons per minute that you're drafting off of. Strainers. So 24 has this strainer, which is called a jet siphon strainer. It's because it's got the inlet for the inch and a half to create a jet siphon without hooking to the truck. 20 has this strainer with the float dock, and then 20 also has a barrel strainer that's sitting in the should be in the engineer's compartment on the shelf. That'd be your last go-to in case that one gets misplaced or flies off the truck. And then some people use the top one to slide in. The two closed one sits on the bottom of the ground, so the dirt and particles off the lake or pond floor don't come up into the pump itself. But you're going to start pulling stuff into the truck. Hose tools are used in conjunction with hose lines. Water does not pass through them. Remember, for the Andrew, Ellen, and John, appliances have water flow through them, tools do not. The most common ones include hose rollers, spanners, hydrant wrenches, hose straps, hose rope, tools, hose clamps, and ramps. Remember, you can have a combination between a spanner and hydrant wrenches. The hydrant bundles on our trucks have the combination spanner with hydrant wrench, and then if you look at the back of 20, underneath the swivel dump, you have a combination spanner and hydrant wrench that usually gets corroded because of all the weather it takes, and it really don't work. The night of the Glacier Pacifier, I actually threw across the street because it wouldn't work. So yeah, I did throw across the street. John was there, threw it all the way back to 20 and cussed it out, so because it wasn't working.
Jeff could use Peterbilt unit that is communicating with Arch 6. They're on fire mutual aid.
Hose tools, hose roller. Don't get confused with the hose roller now. Before, the hose roller was the hose hoist. Since we created the hose roller, it's to drain all the hoses, usually used in 5-inch, because trying to get all that water out of the 5-inch takes a lot of time. You can't walk 5-inch up, right? Because how much water is in it? We were discussing this while we were on break. 1 foot of water in 5 inches, 8.3 pounds. Imagine a 100-foot section. 1 foot times, so 100 foot times 8.3. So much water weight is sitting in that hose. You're not going to lift it. If you did, you're a hawk. If you're not, you're going to pull your back. So once it starts draining out, we'll have 2 people on the hose roller, guy on the source fitting, hold the hose. Everybody else starts walking the hose roller to drain out the water. The hose hoist is used when hose has to be pulled through a window or a roof edge, because of the glass, you don't want it to be cut and punctured. And if you're going up over the top of the roof, say you're not going to use it on a peak roof because the gutters, it's mainly used for, like, if you look at the old brick buildings up in St. Louis, they're square with the asphalt roofs. It sits over there so it can roll over. That's where, if you look in the Fire 1 2 book, they changed the name, so they added hose roller. This is still referred to as a hose roller, but now it's called the hose hoist. So if someone says a hose roller and you bring them the roller, and you go, no, the other one, the hose roller for buildings. Oh, it's called the hoist now. So,
Go ahead.
huh?
Somebody have a rescue?
No, they're landing the helicopter for the funeral.
Really?
Mhm.
That's awesome.
So the spanner and hydrant wrench. The spanner is used to tighten or loosen hose couplings, can open and close gas outlets or gas utilities, and can be used for prying. So if you look right here, that's the gas fitting it can be used for. The newer gas fittings are more narrow and wider, more fatter, so it's kind of hard to get your lug over. And then you can use a prying tool here still. And then usually the gasket fits up here too. And then the coupling goes in there. This is the combination hose and spanner wrench. That's why I threw it in there. Sorry about it being cut off by the picture. And then this is usually the spanner up here, just a lug. So the hydrant wrench is usually operates the hydrant. Usually has a pentagon opening of its head because it's made for a certain pattern. Around here, ours is open, or we can set it on and spin it. You go up to St. Louis City, all their hydrants have a the metal shaft at the top of the hydrant goes over the shape. So they actually have a tool that goes down in and it opens because a lot of people like opening the fire hydrants during the summertime. So it stops them from opening the fire hydrants to open up the water system. Spinner and hydrant wrenches may be combined, which right there, when you have them, we have all kinds of spanners and hydrant wrenches. We have hydrant wrenches, spanners, and we have the combination. So just easier to be familiar with the ones that we use. Hose straps and rope. I know when we did the ladder training, Chief went over the hose strap and rope on how to hook up. The hose strap is used to aid in carrying or handling a charged hose line. It can be used to carry and pull a fire hose, and used to secure hose to a ladder or other fixed objects. So this is the one that you usually use for the ladders. Remember, that goes around the hose, tighten down, and then this sits on the lug of the ladder. Remember, if you're doing that, you loop the hose to get that pressure off of the ladder, because you need that friction loss to help aid in the hose sitting on the ladder. This is the hose rope, where you can wrap it around a charged hose line and hold on to it. Easiest way people do around here is have webbing. They just make a loop, pull it, and then hold the webbing. Sometimes if you see guys on 2.5 by themselves, they'll put it around the 2.5 and then take the loop and put it around their air pack bottle. So it's holding the pressure while they're moving forward with it. There's some videos that you can see them doing it and then holding the nozzle, because being on a 2.5 by yourself, it's a lot of work. Usually you want to make a circle and put everything in there, but it's kind of hard doing that in spaces. Hose clamps. We don't currently have one. DeSoto Rule has one on 5814 and 5824. It's on the side of the pump panel by the engineer. So hose clamps are used to stop the flow of water in hose lines. Let me revert back. We do have one.
Yeah, so I've seen one.
It's on 6228, the little hand clamp ones we use for the portion line. But this is just a bigger one to allow extension of hose or replacement hose without shutting down the water supply. So if you are on, say we have a driveway, we can't go across with 20. You pull the barn load, you run all 200 feet out, then you have the 1.5 inch, that's 120 or 150 feet, and you break the section all the way by the nozzle. Well, you could go back to your second piece, clamp it off there without having the engineer shut down the barn load, take that section off, put the new section on, and keep on going without messing up anything. Use approximate 5 feet from the coupling of the incoming side of the water. So if your hose breaks over here, the next coupling down, you want to come on the water side. So that's on the male end, right? Water's flowing towards the fire, that's the male end. Clamp it 5 feet away, because you don't want to clamp it at the coupling, because you could pull the hose out of the coupling. Using one of these, you never stand over top. You have to do the practical for, you never stand over the top, especially if you're a guy. Stand over on one side of the clamp, and you take your hand, and then you want to slowly push down while bending your knees. But you're going to use your force to push down. It does have a locking mechanism. When you push it down, it will lock in. All right?
You have to get it there.
And if you're using can be used on 5-inch too. And
Mhm.
it's a lot of water stopping. Remember, go slow because you're avoiding a water hammer. Once you get locked in, stay there and keep pressure on because it could be faulty and open back up. So the other one up here on the left is basically it's almost like a clamp. You open it all the way up, put it over, it clips in, and then you just start spinning it down. That's probably the safer one, but this is the ones that a lot of departments have. They actually, I hate to say when I went through Fire 1 and 2, they actually showed a video of someone getting hit in the legs, or in the
Chin.
chin, or in the nuts. Hose ramps are used to prevent damage to hose when vehicles need to cross it. Should be used when vehicle traffic cannot be diverted. We do have 2 sets of these. They're on 6220 up in the coffin box on the driver or passenger side front. They are heavy. If you ever have to get them out, you take them and pass them down the pump panel side, the chrome side, and not the paint side because you have to actually land the truck and drop them down. You don't want to scratch the paint. The chrome is fine. So activity 1-1, see no feel off. So this is the activity we'll be doing with the fittings or the appliances. So you'll be blindfolded and wearing firefighting gloves because we're gonna practice how we play. You'll be given a variety of hose appliances and/or tools, and we'll identify them. You'll have a piece of paper. I'll get here shortly. You'll write your answer down and continue to the next item. While the person's going, everybody else will be out of the room. You guys can take breaks, and then we'll call you in one by one. Miller will, and lift up the box. Or actually, we'll just have the bottles down here because you won't be able to see them. And then you'll feel it, write your answer down, and then move to the next one. Once everybody's done, we'll come back and then see who can identify what type of tools. So I'll get that stuff while we take a break real quick, and then we'll start doing that activity. And then we'll finish up the chapter. Alright, welcome back. We're going to be doing activity 1-1, see no feel all. We're going to have the students come in one by one, blindfolded with firefighting gloves on, and they're going to tell me their answer to what they feel. We will write down their answer and then discuss after everyone has went through. Alright, John.
Yeah, but anybody can see.
Well, not you, come on.
I don't trust you.
Tables in front of you,
And
right there are. That's the first part. First part, work our way down. Just tell me what you think it is.
I'm gonna say hose strap because it's got a strap to it.
Alright, next one. Right there.
It feels like a double mount or a reducer of some sort.
Do you think you know what threads it is,
Mm,
by chance?
It feels like a 2.5 inch to an 1.75 inch. Because it's too big to be forcing line.
Alright, I'll take the answer. Your next one's right to your right there.
That's a ball valve.
Just a ball valve?
Oh, it's it'd be a Wally.
Alright. Next one's to your right.
That's a spanner wrench.
Alright.
the water thief.
Okay, one more. Last one.
That's a Proby tool. That's a whole roller strainer.
Alright.
Is that it?
You're done? You can, you wanna take it?
Oh, I think so.
You can take it off. You answer everything. So, yeah, you got them all. That's the one I was talking about, Chief's favorite one.
Oh,
So it's backwards, 2.5 male. The incident.
that's what got me, because I kept feeling this, but I was like,
well, as soon as you said double, I was like, because he's feeling that.
yeah, I was like, I felt through the gloves, I felt like throwing a tool, so.
You can.
That's what I'm about firefighter gloves.
Alright, it's tough when we come down to the bottom and alright, Robert just finished up. We're gonna have Ellen come in and do it. Who's this?
Okay.
James, okay. James is gonna do it. Coming on up.
So right here.
They're from you. Just tell me what you think it is.
This is bow strap.
Okay. To your right, right there.
This is a reducer.
Do you think you know what size it is?
2.5 to 1.5, 2.5 to 2.
All right, I'll take that answer. Next one.
This is like a gated Y.
All right. Right there.
Spanner wrench.
Okay, next one right there to the right.
This is a clapper or okay, lost the other term.
I know what you're talking about. It's there.
Shoot. I've lost it.
What's it do?
A distributor, distributes water. You're
I'll take that answer.
okay.
Okay, last one to your right, right there. Perfect.
Hose roller.
Right. You are able to take off your hood, and that is a distributor.
Okay.
Or water thief, but we call it distributor.
Yeah, water thief. That's what I was trying to remember. Water thief.
Next.
Jefferson County Channel 2 and 3. Hematite pager.
There's your bar, please.
There's my what?
Right in front of you. Put your hand straight down.
Straight down.
All right. When you think you know what it is, just tell me what you think it is.
It's the ladder hook for the hose. The rope. Not the rope, what's the other thing called? It's for the ladder.
Okay. I'll give you. Okay, come to your right. Everything's gonna be to your right. Come this way. Hands down. Right there.
Male and female? a reducer, male to female.
Do you think you know what size it is by feeling it?
3 to 2.5?
You said 3 to 2.5, or
No, I don't know what size. This is 2.5 to 2 to an inch and a half.
all right, we'll go with that answer. Next one's to your right. Just step one. There you go.
Two females, Siamese to a male.
The Siamese or
Well, it's 2 females. Usually a Siamese is 2 females and 1 male. So it's an appliance.
it is an appliance. What kind of appliance? You're right. It's 2 ends to 1, but which you wanna try and guess again, or
Well, I know it's a gated Y.
is that your answer?
Yeah.
All right, we'll go with that.
I know it's 2 females to a male, so I know it's a Siamese.
All right, next one's to your right. Keep right there. Perfect.
Spanner.
Okay. Next one's to your right. Set this way. Right there.
Water thief. Can feel these. You got 3 connectors and 1 sword.
All right. Come to your right again. Hands right down.
Hose roller.
All right. You can take your head up and send to the next person.
Too bad. I actually have my eyes closed. Next.
Except what that's throwing everybody off.
Well, I told you that. I said that's what's all messed up. Oh, yeah. Right? Yeah.
All right. Turn
Right
right
here?
straight down.
Straight down in front of you.
That's the first one. Just tell me what you think it is after you touch it. Or when you're ready.
That's right, touch it.
Yeah, so you feel it and think you know what it is, just let me know what you think it is.
It's for the hose, it goes on the ladder, pull the hose up. I can't think of what the actual name is though.
Alright, I got your answer. Come to your right, everything's gonna be to your right after you move on to your next one.
Double female.
Is that what you're going with?
Yeah.
Alright.
Bigger than I thought it was gonna be. Gated Y.
Alright, to your right again. Right there.
Spanner.
Alright, you can also. Perfect.
Clapper valve. Hose roller.
Alright,
You can take something.
you take your stuff. So you got everything besides the distributor, which is
Yeah.
this is going towards, and then this is the one that Chief was I was telling Chief I was
Chief
teaching.
was talking about.
So it's actually
Oh.
it is a you can consider a reducer, but it's going from the pump to the fire, so it's actually
Adapter.
adapter. But it's going from a small hose line to a big one. But it's all good. Sit down with Colby for the last one.
Yep. And Eric has to.
Oh, Eric too. That's your first one, Kobe. Everything else will go to your right.
Hose hoist?
Is it hoist or
Or no, not rope, but the other one.
what's it used for? What we
Pulling
do?
hose, I guess. I don't know.
Pulling hose?
Or holding hose, something like that.
Okay. So is it? What's it?
Hose strap, that's what it is.
Okay, we'll go with that. So take your step to your right. Keep going, right there.
Reducer?
Alright, do you think you know what the size is?
2 inch to inch and a half?
You said 2 inch to inch and a half.
Yeah. Probably. I don't know.
Alright, step to your right again. Right there.
My valve?
Y, alright. Step to your right. Right there.
Oh, looks like a hydrant wrench, but it's the other one. What is that? Can't think of the name.
What do you use it for?
Taking off the caps on the hydrant, or the oh, what's that? The things on the truck you connect the hose to.
You're on the lines of what?
You're on the right track, yes.
I don't know.
Alright, come to the next one. Put a question mark on that one.
I don't know what it is.
Okay, step to your right.
Hose on?
Alright, that's the last one. Go ahead to this one.
Spanner.
There you go. You good?
Yep.
Alright, gotta take your hood off real fast. So, you right on the money on almost everything? Distributor.
Oh,
Distributor. Remember, this is the opposite of the clapper. This is going towards the fire.
So you're distributing the water.
Yep. So, this is handles, big one, distribute. Clapper, you don't have handles, alright?
Okay.
Alright, send Eric down for the last one, and then we'll finish up this module.
You can wait till you get down there for that on.
Yep.
Alright, so your first object's right here in front of you, pick it straight down. After you're done with that one, you're going to step to your right, one step, and then your next object will be in.
Hose strap?
Alright. Come to your right, right there in front of you.
Reducer?
Okay, do you think you know what size it is?
Inch and a half.
To what?
2,
Or
two
from
and a half. Or 2 and a half to an inch and a half.
Go ahead and put it down, step to your right. Right there in front of you.
Gated Y.
Okay. Step to your right. Right there. There, perfect.
And spanner wrench.
Okay. Step to your right. Right there.
Clapper.
Alright. Is that what you think it is?
Hang on. No. Gated ball valve. Or gated Y.
Do you have the
Diverter.
different name?
I don't know. Should gated Y?
It's almost like gated line, but it's the bigger one. The
It's supply. Or goes off the truck. It's a diverter, man.
Not a diverter. What's it doing with the water?
Transferring it from a big hose to a small hose during supply.
You're all over it. I'm looking for one specific name, or the two names it has.
There's a clapper. And I forget the other name.
Go to the next one.
We'll go to the next one, we'll go back to that one. Come to the right, last one.
Hose roller.
Okay.
Alright, go back over to your other one. There you go. I mean, you know, he already says what it does. There's really one name.
Diverter? I already said that. Inverter? No. Forgot the name.
Alright, you gotta take your hood off. We'll go over real fast. Distributor. Water thief or distributor? Okay. Alright.
Because it's distributing the water from the truck out to your lines. The other one, you know, it has the valves here, and the water only goes one way.
Okay. So that's a distributor.
No.
And they just kept saying diverter.
No, clapper is going into the truck because it's like a clapper on it.
Yeah, that's why I put my hand in there.
So
See if I can move it.
So,
yeah.
so the water with the clapper, it only goes one way. These here, the water comes this way, so you have to open and close to get the water
So
out.
handle is usually a Y or a distributor, and the clapper is usually you fill up clap. But other than that, good job. We'll sit them down and we'll finish up the chapter, and then we'll review real fast so everybody knows, and then
Sit them all down.
we'll. Wake up. Come on, Peter. Alright, come on over here real fast. I got the computer facing the So, everybody's down here. So, majority of everybody got everything right, okay? Everybody did great. The one thing that got a lot of people was here. The one thing that got everybody, this is the one, the reducer that I was telling you about, our adapter that Chief will get you with. We're going from 1.5 inch female to 2.5 male. So water's coming from the truck from a smaller hose to a larger hose going towards the fire. So that's the only thing that got a lot of everybody, but everybody got the right sizes, but the one, and then remember on the distributor, the clapper does not have handles. It just got the flap in here that will flap, okay? Distributor, the opposite of the clapper. We'll finish up the chapter real fast, so if everyone wants to just sit down real fast. I'll move the computer. Fix that real fast, we're still going. Alright, just to finish out the chapter, it's just the conclusion of module 1 or 2. So, the various devices used are divided up into 2 categories. Remember, there are appliances and tools. appliances are any hardware that in conjunction with the fire hose delivers water and water flows through them. It's the easiest way to remember appliance from a tool. Water goes through the piece of equipment, it's an appliance. Tools are any hardware that are used in conjunction with the fire hose and water does not flow through it. Knowing the differences between each appliance will help deliver water correctly to the fire and not interrupt the flow of water. So that's why we did the blindfold test, because a lot of times fires happen at night and we don't have the sunlight to help light up the area, and if we have a long leg and you have to put different objects in, sometimes you may be told to go down to the distributor and turn off the left hose in the middle of darkness. Like Ellen said, she don't have a flashlight on her gear, so she's going to be doing this in the dark unless she has a light off the fire truck. So just knowing the tools will save you time, especially if you're being the runner. Say you need to get a Y or stuff like that, and you're being told to go to the truck. That's why Chief is always on everybody to know their trucks and know what the tools are. So you can go directly to that compartment, grab it, and come right back instead of doing circles around the truck. If you don't know what a tool is, go to the engineer of that truck. They should know where it is if they're driving the truck. If they don't, they shouldn't be driving the truck. Sometimes if the engineer's not there, you gotta ask whoever's on the truck where that tool is if you don't know what the location is. Usually all the tools that we just touched are in the engineer's compartment. Okay, all the reducers, adapters, appliances, and tools are usually in the first compartment behind the pump panel. So always call it the engineer's compartment. So if you have say like 6314, it's a rear mount pump truck, so the pump's in the very back of the truck. The compartment next to it should be the engineer's compartment, okay? Just knowing tools could help you extinguish a fire faster. Remember, fire grows every second, doubles its size. The longer we take to get water on the fire, the bigger the fire grows. The bigger the fire, the more water we need to overcome the BTUs, and the more tanker shuttles, tankers, whatever we're doing. We're doing tanker supplies, relays, we're doing a water shuttle with the port tanks are running off a hydrant. You gotta overcome the fire, all right? So that's it for Module 2. Does anybody have any questions over what we went over? Module 2. This is, like I said, this is kind of the stuff that we've all went over. Everybody should be going through trucks. It's kind of the boring end of the class, but the fun stuff is the activities and stuff that in Module 3. We do have a lot of information in Module 3 to go over, and then there's 3 activities in Module 3. So we're going to break for lunch, and then we'll kick in Module 3. All right, back to Module 3, water supply operations. This is the big one. This is the, wrong way. So, Module 3 objectives. From the information presented in class with proper equipment, the student will be able to demonstrate how to set up a connection to the hydrant. Information presented in class, the student will be able to differentiate between a forward and reverse leg. Given the proper equipment, the student will demonstrate how to properly set up a port tank operation during a physical or practical activity. And from information presented in class, the student will be able to determine which type of water supply is needed. From information presented in class and given a scenario, the student will be able to define the need for water supply. And the last one, by the end of class, the student shall be able to develop a water supply pre-plan. So, water supply operations. It can be small, like connecting to a single hydrant, or large, like having a port tank operations going as well as hydrants. So connecting to a hydrant that's your only source of water could be a small one. If you throw in the mix like we did on the propane fire down 110, we had tankers going, we had hydrant connection, actually we had 2 hydrants connected, and multiple port tanks going with multiple different sides of water supply. So we had actually 2 water supply systems going, one on the west end and one on the east end. That call at night required everyone from Jefferson County. Everybody's tankers were here, pumpers. We had tankers from St. Francis County and Washington County up here, and we had a first alarm staging company staging at Festus Lewis parking lot for what was it, 5 hours?
That was a lot.
So if stuff went bad, they were the unit to respond in to come recover us. That was everybody from Rock Community up to Melville to Valley Park. They were all in Festus Lewis parking lot sitting there. That's where the job was, sit there until either being released or come to the scene and after the catastrophic event. And that would have been the propane tank blown up. Luckily the propane tank didn't blow up and we got everything under control, but that big call required so much water to be used. We probably used over, I would just an estimate, probably over 200,000 gallons of water. And this was we had tankers going to our water tower, we had tankers going all the way up to Festus, tankers going all the way back into the city of DeSoto. So we had actually 3 water districts being tapped for water. Besides fire extinguishment, water supply is one of the key steps in firefighting. Without water supply, we would never get the fire under control. In this module, we will go over connecting to a hydrant, forward lay, reverse lay, port tank, and tanker relay operations. Fire hose 3-3.1. Different diameters, own specific purpose. Size of the hose is an inner diameter. Made into 50 or 100 foot sections. Different size hose goes from 1 inch to 6 inch hose. Attack hose and supply hose. 6 inch hose is the hard section, which is hard plastic with a metal ring around it, okay? So it cannot collapse on itself. If you use 5 inch for drafting, it would collapse on itself from the suction and cut itself off. So 6 inch, if you ever heard of 6 inch, it's drafting hard suction. It's used for drafting. The biggest size of hose that's on top of the fire truck around here is 5 inch. If you go to Cedar Hill, they use 3 inch. There's no 5 inch on Cedar Hill's trucks. 2.5 and 3 inch has the same couplings here at Hematite. We just use that because for the clapper and for the distributor has 2.5 inch couplings. So then the 3 inch has 2.5 inch couplings also. It's just so you don't have multiple couplings that you have to have reducers or adapters to connect in to each other. 1.5 inch or 1 3/4 inch is our go-to hose. So here we use 1.5 inch. Festus, R7, DeSoto Rural, DeSoto City, they all have 1 3/4 inch. It's only a quarter size bigger. Now you think, well, I got a bigger hose. Yeah, you got a bigger hose, but now you have to supply that hose, and being that much off on your pump will either benefit or be a disadvantage to you on firefighting. Everybody around here supplies their 1.5 inch or 1 3/4 inch at 120 psi at the nozzle or at the pump. We pump at 175 to create that friction loss. Chief's been talking about his water supply class. There's apps out there. You have Elkhart Brass, or let's see what this other one's on my phone. You have Elkhart good to have both of them because, example, I asked Cody what Festus pumps their engine 3/4 at. He goes, I pump at 120. I said, well, you're below pressure. He goes, well, that's what they want me to pump at. I said, well, go back and tell them that you're below pressure. So you're giving inadequate water for the fire. So if you have a big fire, you're not overcoming the BTUs of the fire. So with the right hose and the right pressures, you'll overcome the fire. That's why, like I said, we pump 175 at the pump for the yellow hose, and if you pull the red hose, we pump at 120 because of the size of the hose. And the pressure. If you're on the red line and you at 175, you're going to be moving because you're going to be fighting. So remember, big water, big fire, you need a 2.5. So 1.5 inches and 3/4 gives us about 125 to 140 psi, or gallons per minute at the nozzle. 2.5 gives us 250. Remember how long you can flow before running out of water. So remember, depending on how many hoses you have on ground, this is where John, me, and Robert knows. You put hoses on ground, you better have the gallons per minute to meet that standard, because 2.5 inches on ground, that's 250 gallons a minute that you're flowing. You put 2.5 down with them too, you're flowing 500 gallons a minute. And before this year, when we did hydrant testing, majority of our hydrants were 550. With the new addition to this line on Karen Road, we raised the firehouse's hydrant from 550 to 750. But remember, that water is off a tower. You're only going to have the water for so long until the tower runs out. Lane line and pick in what size. 3-inch is typically used for tinker sites, okay? You are filling off the hydrant. Usually, a majority of the hydrants around here have, just like the firehouse one here, we'll go over here for one of our activities. It just has 2.5 outlets. The main shaft of that hydrant is a 4.5 inch pipe. All right, so that is supplying through the 4.5 inch pipe to the 2.5 inch outlets. Then we use 3-inch to offload into the clapper on 20. So if you're using the clapper, remember, have the 3-inch off 23 in the clapper, and make sure if you have tankers that are stacking up, you can run more 3-inch or 2.5 inch back to them, but 3-inch would be the way to go because it's the bigger size to give you a little bit more volume. All right, so 3-inch can supply up to 600 gallons per minute. 5-inch can supply up to 2,000 gallons a minute, but you gotta have the water source to supply that. Advantages and disadvantages. So dual 3-inch offers more reliable supply. All right, you may think it's smaller than 5-inch, but you gotta remember you're having 2 3-inch lines to make 6 inches, but 5-inch larger quantities of water over longer distances at low engine speed. That's where Josh was talking to you, James, about using 5-inch. We can fill all the 5-inch on 20 with 20's tank, but we won't have water at the attack pumper. That's why you need a tanker or hydrant to supply the rest. 3-inch can only go so far before you have to start pushing water. 5-inch can go a mile. Has everybody seen on YouTube them laying 5-inch with the truck that only has 5-inch in it? There's no tank. It's like the length of 20 all the way down, full of 5-inch, and he's doing about 60 miles per hour down the road, and it's just whizzing out. You can do tank relays up to a mile. Just depends on, you have to put pumpers in between stuff. If you look on the pump panel on 20 and 24, there's diagrams on there that tells you how far you can lay. So we could actually pump over 3,000 feet at like 55 psi off the pump because of slow engine speed. But we got the volume, and you don't need the pressure. But pumpers do space out, and 5-inch to stretch farther than 3-inch when being supplied off the hydrant. So, like I said, up in the top, we'll go over when we do the. I'll show you guys when we set the port tanks on how far and the feet where each pumper needs to be set or sitting at. So switching from fire hose to connecting to the hydrant. So you may think connecting to a hydrant is simple, but it's not. A lot of the fire departments around here, especially us, we have our own water supply pre-plans. So we have specific hydrants that if it's in with multiple hydrants, like say Olympian Village, we test each fire hydrant, right? We don't do it in the runs because we can't get the right pressures like that, like the city of St. Louis can do. We go to each one and test each one. So we have specific hydrants that we can hit inside of Olympian Village with the greater or higher PSI for gallons per minute. So it's basically like you need to lay from this hydrant or that hydrant. So you need to know what hydrant you're hitting. On our Rover app, it'll tell you which hydrant has the highest gallons per minute, stuff like that. You may be confused, but as firefighters, we should know which hydrant we should connect to. Like I said, we have water supply pre-plans for any house with a driveway over 500 feet. So it took me and Chief about 3 months to do this with Google Maps. We went through the whole district and all the driveways that we found that were over 500 feet, and we set water supply pre-plans. It's in Rover, it'll pop up, say water supply pre-plan for that address. You click on it and it'll tell you exactly what to do. So based off the coefficient of 3-inch at 0.72 and 5-inch at 0.08. Hydrant pressure needs to be flowed at 400 gallons per minute through one 300-foot supply line, allowing 20 psi for the residual. This is a lot of math that the pump operators have to know, but it's a way to show you guys what you have to do. So 3-inch hose, 55 psi, that's how much pressure you need on it. 5-inch hose, you need 24 psi. Does that make sense at all? For hydrants? So, hydrant pressure needed to flow 400 gallons per minute through one 300-foot supply line. You gotta allow for 20 psi for residual. That's what the hydrant's putting out, at least 20 psi. So a 3-inch hose, you need 55 psi. For a 5-inch hose, you only need 24 psi. You cut it in half, because that's when it's going back to supplying 5-inch at engine speed instead of throttling up because of the size of the hose. With hydrant pressure of 65 psi and flowing 500 gallons per minute compared to the following distances. Remember, 20 psi off the hydrant, 3-inch hose, 250 feet. 5-inch hose can flow 2,250 feet. That's the difference between what 3-inch can do and what 5-inch can do. That makes sense. Does that make sense at all? These are the flows that you would have to. So 250 feet is the max what a 3-inch hose can supply with 65 psi without having a pump. All right. 5-inch hose, it has to. Remember, 5-inch fill up, it'll go back. It'll fill up more and go back, and fill up more and go back. Does it make sense? You gotta let 5-inch hose fill up to keep water moving. So, continue to connecting to the fire vent or connecting to the hydrant. So it takes so much water to overcome the BTUs. BTUs is British thermal units in a fire. Okay, so this is where you need to think. Would you rather hook to a 250 gallon per minute hydrant or a 550 gallon per minute hydrant? 550. You get into, so, city of Festus. Usually cities, the hydrants, lays, how they run their pipes is not on the same mains. Alright, this main comes up, cuts this way, cuts around, this main cuts through, alright, because you don't want to hit the same main, because you don't want to rob Peter to pay Paul. Alright, if you have 2 hydrants, like you see all St. Louis City doing all these big fires, they hit multiple hydrants. Well, them hydrants are on different mains. So you can supply all them trucks. If you hit this hydrant, Like when Bandana's caught on fire, they wanted us to hit the hydrant at CVS Pharmacy. Well, that hydrant is on the same main as the hydrant that hit in front of Bandana's. So when we turned this hydrant on, we had no water because they were already taking water out of this hydrant. So that's why we disconnected from CVS Pharmacy. Hillsborough come in and connected on the Festus main between Walgreens and McDonald's and supplied from there. And then we hit a third hydrant off of Main Street, well, Bailey, by right behind the restaurant stoplight. Hydrant right there, we hit that. That hydrant's off Crystal City also, which only gave us like 300 gallons a minute. It's on one of the dead ends.
Well, didn't they open up the gate between Festus and Crystal?
Nope.
Oh,
No,
yeah.
we didn't- not that. That was on
Oh,
the
okay.
Chinese restaurant. They opened it up. But yeah, so picking hydrants need to be which one you're gonna hit.
So the Bandana's hydrant in the Gordon's, that wasn't on this.
No, it's on a different main. But the one behind Gordon's was on a dead end. It's the one of the last ones on Crystal City before you get to Festus.
Mm.
Yeah, 'cause
So-
there's a gate right up,
Right by
a couple
Music
hundred feet
World.
up there, there's a
Yeah.
gate right there, it stops it.
Yeah, so right at about Music World between Festus City and Crystal City, there's a gate that they have that they can supply both cities with. It's one water district goes down. So if it
So
ain't
like the Main
open,
Street fire, we opened that up,
yes,
so we got water from Crystal City during the Main Street fire.
Yeah. this helps supply because on the Main Street fires they had multiple. So the Main Street Cafe fire, they had a line from almost Festus Firehouse down, one from Adam Street and Main Street down, one from the back of Main Street by South Second up. So they had multiple hydrants, but when you pick the hydrant, you need to make sure you're not on the same mains. That's why when we have tanker shuttles, we have certain tanker sites that you guys go to. That's why we tell you go to Karen Meyer, or we go down to Lee Road, or we go out the Falls of Little Creek, or in the city of Festus, or vice versa. It's easier to go down 67 by Olympia Village because there's 3 different mains all right there in that area. You come up over here, the Karen Water Tower controls everything right here in this general location of the firehouse. So if you go down to Blackwoods and open up that fire hydrant, you just drained the whole entire top of the hill here. When we did hydrant testing, when I tested that hydrant, for 5 minutes, Chief couldn't flush toilet here. That's how we sucked the water all the way down. He couldn't even flush the toilet, or he flushed the toilet, he couldn't fill the toilet, and he couldn't wash his hands. He thought I broke a water line. He called me, "What'd you break?" I didn't break nothing. "What hydrant you on?" "Blackwoods." "Oh, fuck." He said, that's what his exact words of water. So they have pressure, but they don't have volume.
So if we were to have a trailer fire in the park,
But
and you did a tanker,
Go ahead.
you did a tanker shuttle, you wouldn't be able to go to Blackwoods because then if you were hitting a hydrant in the trailer park,
You couldn't, if you had a house, so say, on the trailer park, we just use tank water. A normal size trailer should be less than 10,000 gallons of water.
right? I'm just
No,
using
no,
as
If
an
you take
example.
one Beezer's house coming
Yeah,
fire.
take Dave's house on fire.
If you hit this hydrant here, and then you still need, let's say
Water.
they're hook up a ladder truck or whatever, well, that's not gonna work, but you take a, 23 down there to Blackwoods, well, you just fuck them up here.
Yeah.
'Cause
Gotcha.
now you just
Water's
drain
gonna
it,
flow downhill. Water flows on.
Well, like in the Summer Main Street fire, everything on top of the hill
Yep.
without a water, but we're getting
Yeah.
water down the
Yeah.
bottom of the hill.
Remember, gravity controls where water goes. So that's why one tanker site is Lee Road at Meyer Road, down there at the bottom.
Mhm.
You have everything coming off Lee Road, you have everything coming off Meyer from the top side of the firehouse, going towards town. You'll drain Lee Road and you'll drain the top of Meyer Road, because everything's coming down to the hydrant. Once you open up the hydrant, you just open up a hole, and that's where it's gonna go to. Alright?
So if Dave's house caught on fire, we should go to
Yeah.
Lee Road.
No, that's on the same main as the firehouse here.
That you'd
So
say at the
if you need
firehouse.
tanker, if say Dave's house caught on fire and we needed tankers to run, the closest tanker fill sites from here is Festus Water Tower off of Gamble Cemetery at the
Church.
Radiant Life Church. That's how far you have to go.
Wow.
Couldn't you just go across 67 and hit a different main though?
It's on the same main.
I think you said there's 3 different ones over there.
So CC, it's on its own main, but the water over there is so crappy, you won't be able to supply a line. If the one hydrant at the bottom of Meyer and 67 on Clayton Mobile Homes was open and running because they broke it, we didn't break it. Well, I broke it about 4 years ago, but they fixed it. And then the people that just bought it ran into it with their tractor, so they snapped the pipe off at the bottom of the valve. If you open that up, you could supply, but because it's coming downhill, but that's offline, you would have to go all the way up to Meyer on CC side and hit that hydrant, and that hydrant can only do about 500 gallons a minute. So now the firehouse hydrant, we just tested it this year, can do 750 now. We went up 200 gallons per minute with the line they put in on down Karen, water district in. But yeah, in this general area, the Karen Road tower controls everything. That's it. It controls all the way down into town of Hematite. It controls all the way down to town of Victoria. It controls everything down to Dual Road and down to Sunnyside. That's the biggest area that water tower controls. Then it runs down Meyer to 67 and runs on the west side of the highway on Surdeck side all the way down to Buffs, and it runs up over into Stonegate and then up the hill to CC. There's a map right there from the water if you guys want to look at it. So picking the hydrant is where you gotta know what hydrant you're hitting. That's why, like I said, we do hydrant testing every year because one calculation they do can affect the whole water system at the for us. So that's why we test. They get mad at us, but my chief tells me it's better for us to break something during normal time instead of on a fire and someone dies.
Mm-hmm.
And then they're gonna say, "Why didn't you have water?" Well, water department's line broke. I mean, I know Chief hammers us on open and closing the fire hydrant slowly around here. Open and close them slowly. Let's see, where were we? Depending on which type of supply hose you have and the type of hydrant depends on how we connect. You can have single or double 3-inch or 4 or 5-inch. Because you go to San Francisco County, they run 4-inch. Up here we run 5-inch, so City runs 3-inch. Just depends. If it's right here, like say Dave's house is on fire, we're gonna pull the hydrant bundle off, run our 5-inch right in, and then hook it right in the 20. If we need to go into a more complex firefighting operation, we'll set 4 tanks if we need to, or we'll set tankers shuttles. So this is different types of hose loads. So the top left one, that's accordion 3-inch. So one side of the hose, usually right here, is your forward, this side is your reverse. And usually what they do is they connect both of them together. The easiest thing to do is have them connected both together. You take it, you pull it off, drop it right over on the, take it over the hydrant, and they can take off. 5-inch on the other hand, you have to pull the 5-inch off, wrap it around the hydrant a couple times, and then have them take off. Let's see. If you have a single leg, first thing you do is make a couple loops around the fire hydrant, then throw the rope over the hydrant. The reason why the rope's there is because the bundle's wrapped up, and if for some reason the truck pulls the loops off, the rope will catch it. It's just a safety to the safety. If you have dual lays, just wrap each lay around or throw the connection around it because it's already connected to each other, and then let the pumper drive away. Remember, if you're doing what you would cover in a reverse lay, always take your hydrant bundles with you to the hydrant if you're doing a reverse lay. Never just hold the hose and have the pumper drive away. One, you may be drugged behind the fire truck, or lose the hose you're holding, and then the hose is being pulled behind the truck, and then you just lost your supply hose. Then you have to redo it all over. Make sure all equipment is there for you to hook up. Like we said, usually fire departments have hydrant bundles with various types of adapters to hook up to the hydrant. Let you guys write that down real fast. Everybody good? So this is just a couple different ways, fire hydrants. So the top left one, it is just a 2.5 inches, like we have up at Firehouse, and then but they have actually a modified hydrant. So it actually has the 2.5 here, but they have a 4-inch here, which is kind of cool, steamer valve. And then this is the steamer ones that we have. And the new line on Karen has this one, and then Blackwoods has the steamer valve. Everybody understand what the steamer is? No. Steamer valve is a 4.5-inch opening on the fire hydrant. So you have your 2.5s on the sides, and then you have the big one in the middle. That's called the steamer. Then the bags, they have bags. So DeSoto Rule has a bag on the back end of the truck, or over on their steps if they have the mid-mount pumps. They raise up and grab the hose load or hydrant bundle out. Ours is connected to the end of the hose. Like I said, just wrapped up with all of our fittings. Making the connection. First thing you want to do is flush the hydrant to clear the debris, then hook up the applications. We don't have the problem down here, but St. Louis City, a lot of people, homeless people like to stash their drugs in hydrants. They throw trash down hydrants, they put beer cans in there, all kinds of stuff. That's why we flush the hydrants to make sure that all that shit gets out of it. Unless there's an object in the way, car, wall, etc., the hose always goes closest to the fire. That's our rule here. Hose closest to fire, gate valve on the other side. Okay, the gate valve is never connected to the hose. Alright? Everybody know why the gate valve does not go inside the hose? Usually John and Ellen probably could. If you're pumping up a hill, alright, from the hydrant, you have a truck down, or you have the hydrant here, it's able to supply the truck on the hill. When you're done fighting fire, where's all that water gotta go? Downhill. On the bottom of the fire hydrant, it's only a, I think I have it on here.
It was like a half
no.
inch. An inch. She said it the other day.
It's like an inch valve at the bottom of the
drain valve.
drain valve. It's about only like an inch. That's all.
The last one, no.
First one?
No, last line.
Last one.
Wow.
So all that water has to come down the hose into the fire hydrant.
Sorry. It's just a respect thing.
All right. Yes, so it has a 1-inch foot valve at the bottom of the hydrant, which when we get there, that'll be one of your fill-in blanks. Just checked my instructor guide. It only drains when the hydrant is fully off. So while the hydrant's on, it's closed. So, like I said, the water side goes somewhere. So if you disconnect the truck, you have a guy go down to the hydrant, open up the gate valve, all the water runs through the hose, out the gate valve onto the ground, you drain your hose. And then whatever's left in the barrel of the hydrant just drains out through the 1-inch foot valve. But if you don't have it on there, it's gonna be a long time before that thing drains.
Be a long night.
Because you lay, depending on how much hose you lay and how much water you fill, 1 inch, so you would lay 1,000 feet of 5-inch up the hydrant, that's 1,000 feet of water going through a 1-inch foot valve.
Chief would not be happy.
Mm-hmm.
So, it'd be, can we come back later and get this hose? So, usually the setup for a double 2.5 gate valve hose. Alright, it has everything. Just take the gate valve off, put it on, open up both caps, put everything on after you flush it, and away you go. Just make sure the hose is connected at the truck. If there is a steamer, which is always usually 4.5 inch, you usually hook up your fitting up to that, and then the gate valve to one of the sides. On some steamers around here, usually you have to disconnect the 2.5 female, so 5 inch source off of it, and use the 4.5 female to thread onto the steamer. In City of Festus, or probably DeSoto City or DeSoto or city that had set up, they have the source fitting already set up. Just take the cap off, hook the 5 inch right up to the source fitting, and all of the other valves sit on the ground. One more way. You going the right way? So again, remember, open and close the hydrant slowly. Why?
Water
Again,
hand.
back to mod 1. There's pressures that we have with water. You can water hammer the system. Also, you need to be listening to the radio when to open the hydrant. Usually a universal sign, if you don't have a radio, is when the pumper at the scene hits its air horn. You'll hear it, air horn, and it'll stay constant. Okay? The other universal sign for with air horn is 3. You just hit your air horns, means they evacuate the building. But usually at the beginning of the initial fire attack, if the pump operator hits the air horn, it's to let the guy at the hydrant know to turn on hydrant if you don't have a radio. You may ask why I put a gate valve on the hydrant. Again, back to module 1, you have pressures, and if you're downhill, you cannot uncouple the hose. John, were you on the Peebly Point fire?
No,
when
I
it
was
caught on
here.
fire? You were here?
Yeah.
So Chief witnessed a guy disconnect 5 inch from a fire hydrant that was under pressure that was still flowing water. When he disconnected it, it blew him and the hose across the parking lot and underneath one of the cop cars. The cop car stopped them from keep on going with the water. So much pressure was on this hydrant because one, it's in the city of Peebly. They have good water. Usually cities have good water, and it blew them all the way across. Has everybody seen the video of the guy? I don't know if it was New York,
Yeah.
where he was actually tightening the valve, the female thread on the hydrant because it was leaking. He was tightening it. There was so much pressure when he touched it, it blew off. And everybody was, all the comments, well, he was listening. No, if you see with the way he was going, he was tightening the valve. One, it wasn't all the way on there, so it was probably a thread or two. When he put it on there, it went poof, and he went poof. And it was just 2.5 inch. It wasn't even a steamer. He was on one of the with 5 inch hose, and it just blew him off, and he went. Water's got pressure. So here's usually hydrants have 1 inch foot valves that only open when the hydrant is fully closed. That would take a long time to drain, depending on how much hose is on the ground. Also, when the hydrant is being turned on, it ain't halfway on, it's all the way on or not all the way on. Open fully or closed fully. Okay, because what's happening is if you have that foot, if you turn the hydrant on so many times, the valve's not all the way on, you're restricting your flow, and then you could have that foot valve could be stuck real quick, and water could be draining out on the ground. You know, if you got water going into the ground, you're creating the ground around it to become loose because you're basically like a sprinkler system, you're watering the grass. And if you have a system failure, you can actually pull the hydrant out of the ground. Alright?
Goldman actually did that.
Yeah. Who?
Goldman.
Oh yeah, Goldman actually pulled the hydrant out. That hydrant will come up.
Oh yeah, I heard about that. Bubs
It was
told me.
like 5 feet when it came up.
It's on the water district.
All the way off, all the way on. When you go to turn it off, you take it all the way till it's tight, and then take the spinner wrench back, or the hydrant wrench back, 1 full turn, because you want to leave it loose. never take it this hydrant wrench and tighten it all the way down. All right, you're putting, it's just a valve that comes down and it's got shear pins in it. All right, if you go tight,
There used to be a picture somewhere.
it was taken down. I don't know where it went to. It's just got shear pins. Around here, our fire hydrants are dry barrels. All right, you go down to Florida, you go down to Texas on the southern end, they have wet barrels. Water all the way up to the top of the bottom of the hydrant. All right. There is a valve that stops it from coming out of the hydrant. So you see all these movies where they run over a hydrant, say in New York, and the water comes out. Well, they don't work. That's fake. Now down in Florida, it could happen because that valve is sitting at ground level. Here, our valves are underneath the frost line, which is usually about, what, 4 to 6 feet below the feet because of the frost line. So it has to be that far down. That's where the water is. Usually, water that comes out of the ground is about 55 degrees. All right. Remember, caves are, before we built houses, we lived in caves because it stayed a temperature of like 55 degrees all the way around. But when temperatures drop, the cave temperature would drop at the very top. So you gotta get the underneath the frost line. When you build a house, your foundation has to go below the frost line first. It's all building construction stuff you'll learn. But yes. So if a hydrant sit in here in our area, you won't have water spraying up out of the ground, stuff like that. Now if you break the hydrant like I did, the hydrant's gonna shut off and throw the hydrant wrench up in the air because the valve or the rod blew, that comes flying up, and then you blow the line off the ground, and then the ground starts shaking, and you're like earthquaking and snow. You got water shooting out everywhere. So that's why you just gotta go slow. And then they're like, "Oh, you went too fast." Like, no, I went slow. It was hard to. I was shaking when I was turning it off. So I mean, the one at Blackwood or down Blackwoods, it will shake the ground in your hands when you're opening it up. So activity 2.1 is called wrap and tap. So this is where you'll use your gloves. You'll be given a variety of hoses, appliances, and or tools, and will hook to a hydrant. You'll demonstrate how to wrap and tap a hydrant. So I'm going to pause the video. 1 second. Alright guys, so this is activity 2-1, wrap and tap. Skill objective is the candidate, you guys, and demonstrate how to properly set up a connection to the hydrant. Skill instructions: while wearing structural fire gloves and a helmet, you'll be given a variety of hose appliances and or tools. You will need to hook to the hydrant. You demonstrate how to wrap and tap the hydrant. So on your skill sheets is, first thing you need to do is don your gloves. Second thing you need to do is correctly select the proper equipment. On flushing the hydrant, we're just going to verbalize that you flushed the hydrant, okay? Did the candidate correctly demonstrate how to wrap the supply hose? Did the candidate correctly set up the equipment on the hydrant? So we have the 50-foot section of 5-inch here. This is just going to be demonstrating on when you pull out the truck. So I don't want to pull the 100-foot off, so we're just going to have the 50-foot here. So when you pull it off the back of the truck, you got to undo the back tarp, get it undone, grab the loop that is back there, and pull. Now remember, the hydrant bundle is wrapped up in there, so you're going to have a little weight, okay? So you got to pull that off and then take it to your hydrant, okay? So pull that out. Okay, so we have the 5-inch here. So you will have another one in between the source connection here and the 4.5 female. Alright, so this is your variety of tools. You're going to hook up to the hydrant, okay? Who wants to go first? Alright, so you have your variety of tools and appliances. You need to wrap the hydrant first and then get ready to set up.
When I would flush the valve, I would.
Yeah, so you would pop both of them off. So go ahead and take them both off. Try the other way. Nope. The firehouse's one shouldn't be tight because it will offset quite a bit.
So then I would turn it on slowly till I get some water flow, then open it up, let all the debris and dirty water come out, close it back up. I'm going to, depending on which way I was going, right?
Yep, depending on where the fire is. So we'll just set the fire towards the firehouse.
I have a valve here. And then if I was going to run another hose or have it.
Yeah, so real quick, you can take the 8 valve. That would go over there. And then after the truck's going, go ahead and grab your
Here and do that.
this one come off. You might want to grab the 5-inch spanners. You got it. Just kidding.
Got it?
Yeah. Take it. Undo it from the fire hydrant. Put it on. Turn on your water. Let it fill up. Make sure this is closed. And away you go. But understand? The thing with the hydrants here is, like I said, you have your 5-inch doors, the 4.5 female, a double 4.5 female here with the threads on it. So in the city of Festus, you would have basically this backwards. So this would be a female connected onto the steamer that would sit right here. They would have a cap on this. Take the cap off. Just take this 5-inch and just connect right into the source here. The 2.5s would be off to the side, and then you would just have the gate valve on one of the sides. Does that make sense too? Because remember, the steamer, this barrel, if you look at the back side, it'll tell you everything about the hydrant, where it was made, the size of it. It says 4.5. It's 4.5 barrel for the hydrant off of the main. And then the easiest way to figure out where the main is in case you blow the hydrant is it should be back over here. So this one
I think it's behind you more.
Go in there.
The other one's underneath the truck, isn't it?
That's for the firehouse.
Oh.
And then you got the water meter here. So, just remember your mains usually run off to the side. Right off the front since you work in the water district. It's usually, so that line comes down my ear here and goes this way. This comes off and goes into where that valve is. So this just tells you where your line runs with the valve. Good way to know. We can go hydrant testing, see where your shutoffs are to see where your main line is. We'll break down real fast and then we'll do more to do it. And then we'll go to our next activity of doing 4 tanks and setting up single and dual tanks. Alright, so let's go now. Don't be shy.
Well, I was gonna ask you, would you rather have like fruits
The-
do
the
more?
new one-
do you
the
want
new one's
us
gonna
to
do
do
it.
it? Like, what? It's totally up to you.
Kobe, get in here. You need to learn how to do this. It's a good job for you, especially when you start getting on trucks. So you want to wrap just a little bit more in case the truck pulls the hose. So if I was the truck and I pulled your hose, you want to make sure it don't come off that hydrant. And with you doing it extra times, that just gives you more hose in case it pulls it tight that you can undo it and have enough room to work around. So do like a loop or 2 or 2 loops or 3 so you can have that extra hose right there in case you need to mess with a car that's in your way or any objects. That'd be good. Then you would tell the truck driver to go, and then he'll take off. And then, when you see the hose, so when it's first being pulled, the hose is gonna be pulled up like this. Once you get so far out, I would wait like until you hear the first coupling hit the ground before you disconnect the hose, because it could get snagged up in the hose bed and pull again. So make sure that they get a couple 100 feet away if you're doing a long lay. So, I mean, coupling's up there, it's all tight, gets snagged. You want to unwrap? When you get done wrapping, then go ahead and hook up. Do your steps. look at your hose and look at the application you need to do.
Forget which goes to which.
Where's your hose at?
And you pull your hose and look at your hose and all that.
So we have what kind of fitting? What kind of fitting is that?
Forget the name of it.
Stores?
Stores?
So we need stores to what?
Stores?
To what's the size of the fire hydrant?
2 inch now?
Which one's stores to 2.5 inch? There you go. Left to loose your right tighty, bud. Do you need those?
No.
You
They
don't need
just wanted me to put them together or not?
No, just put them down on the ground. And then after you got all everything hooked up, what would you do?
Turn it on?
Turn on the hydrant. Now what'd you do?
That wasn't what happened.
What are you supposed to do before you hook up?
Oh, flush it out.
Flush that. So real quick with how if this was all connected, what happens when you turn the hose on?
You're gonna get
Alright.
screwed.
Twist.
You're gonna get
Twist.
screwed.
Alright. This does have a swivel on it. But if you tighten on the 2.5 all the way, it will tighten up the valve or the fitting here and then lock it into place. So then when it turns it on, it's gonna try and
It's
flip
gonna
this hose all
twist
the way
it.
down to where it either flips all the way down to the truck or it kinks itself up. So make sure when you set your 5-inch hook, just throw it off to the side in line and then turn it on. Alright? Seem easy?
Yeah.
Alright, let's disconnect real fast. You got a lock over there. So you turn it real fast. See a lock? There you go. Lefty loose, you're already tidy. Where you going?
Left?
Go the other way then.
There we go.
Oh, wait. Yeah.
Next.
open it up, flush it out.
All right.
Watch your toes.
If I understand hooking to a hydrant, just remember, like we were talking in class, right here is the shear pin. So in case the hydrant gets hit by a car, it shears off right here at these bolts. And then, like I said, the valve is to shut the hydrant off is about 4 feet down because of the frost line. Just depends on, like I said, your elevation, and if it's running right here on the side of the hill, it needs to be probably further down and over because the frost line can penetrate from the side. Probably would know more about the being on the water department, how they installed everything. But like I said, when I broke the one down there at Myron 67, I was turning it off after fully being on and running it. Was shutting off slowly. The hydrant broke inside, which sent this flying up in the air, and this come out of the fire hydrant about 3 inches, and then probably where Andrew's sitting, that's where my road is on the east side, and water just started coming out of the ground like a someone turned the faucet on. So yeah, it was fun. Look, I didn't get hit in the face. No, don't put your face over it for safety reasons in case that happens. So usually a lot of times the hydrants tell you which way is on. Your hydrants have the arrows. They try to make it damage proof. Like I said, when you tighten it down, that's tight. Come back, or it can swivel back and forth easy. It's still off, but it ain't tight. So when you come up, you go the opposite way on accident. You're like, oh, and then you get shear the pin off too. Then your hydrant's out of service. Remember, lefty loosey, righty tighty, counterclockwise is open. Stop the video, John. Alright, forward leg. What is that forward leg? Laying the supply hose in from the hydrant or water supply to the fire or supply or the tech pumper. Alright, so these are the key rules. Like Miller was talking to me about his cousin up in Michigan. You don't want to be like them because then you have to pick up all your hose for no fire. I don't know if you want to explain to them what they did?
Now they're just going to supposedly a house fire, and they had heavy smoke. So when they hit the driveway, all it's a long driveway, so they laid from the road in, came around the corner, and then all it was a barrel.
Oh no.
And they didn't even put the barrel out. That's what burned.
Don't be like them. We don't want to lay line for stuff like that. Any driveway over 100 feet, we lay line in. Why? Our crosslays are only 200 feet.
Because the other 100 foot's going in the house.
Yes. And if you have a 2-story house, you need more hoses to go upstairs.
Right.
If you go in the basement, you need hoses to go in the basement. So anything over 200 or 100 foot, we lay in. It could be 50 foot of 5-inch underground and a pumper. It could be 1,000 feet, pumper. But that's so like anything over 100 feet, we lay in. That's our rule, Chiefs Code rule, blah blah blah. Like I said, crosslays are usually 200 feet, which takes half of the crosslay, which would limit you on your advancement into the structure. Let you guys write that down real fast. The main pumper can lay in if you have confirmation of a working fire. Okay, so if you guys are on, if we get a fire today, we're all here. John could be driving 20, I could be driving 20, 30, it doesn't matter, one of us is going to be in one of the trucks because we have a crap ton of people here. If we do not have confirmation of a working fire, them 2 trucks will go into the scene. Why? I have 23 right behind me, or John has 23. There's 1,600 gallons of water on 23. There's 1,500 gallons on 20. You have 3,100 gallons of water on scene because we're right. Whoever's running 23 is going to be right on 20's ass.
Right.
Right? So if you don't have confirmation to working fire, do not lay in. Usually, if you have a pumper that comes in, so 20 goes in scene, advises working fire. Next in pumper, lay in, or next in pumper, come to the scene, lay out. That's where you got to make your decisions on: can we set water supply in at the scene, or do we need to set it on the road? But you should not lay in when you have rescue or do not have confirmation on a working fire. If you have a confirmation of a rescue, your job is life safety first. Okay, life over property every day. Okay. Do not need to lay in for a bonfire. John's cousin laid in for a barrel fire. Shit ton of smoke, but it wasn't a house fire. And then you have to pick all that hose up. Imagine laying that in 1,500 feet down the driveway. Get there and it's a
That would suck.
farm
so
barrel
bad.
or a pile of leaves on fire.
Or 67 highway.
Yeah, that too.
Scott, wasn't that Scott?
Laying it down the highway, I don't remember.
Like 5-inch.
Once you get in there, the second pumper in sets up water supply. Festus's golden rule on any of their fires: the second in truck hits the hydrant, unless they are telling you come to the scene first. Back to Glacier Pass, the fire on 4th of July. We were second truck in, we set water supply. It took a little bit because nothing wanted to go our way, and valves and hose was stuck, and we had to cuss at each other and cussing out the truck and cussing out equipment, and then had the PD help us and had some people, other owners help us get hose off 20 because it got stuck. Actually, I had to climb all up on 20, disconnect or undo the tarp to get hose off 20 because it got snagged on the hose bed. Now, if we laid it, I would just rip the shit out of it and fix the tarp later.
So should you not lay in if you have an exposure problem also?
No. Do not lay in if there's an exposure. If you have either someone trapped or you have a secondary structure getting ready to light off, that's your primary right there. Get the water on the fire, calm that shit down, or get inside and try and find out where the patient is. So you put water in that room, or get a ladder to that window
or like he said, he got 3,100 gallons.
Yeah.
As soon as we get there, and then you're probably looking at just a few minutes before the next truck would be close, and then they can always, if there's a hydrant, you can always hit the hydrant then.
You're gonna knock a lot of fire with 30,000 gallons of water.
If on a good day here, 20 and 23 can get out simultaneously, or 23 is like 2 minutes behind 20. Bad days, 23 and 24 don't get out. On good days, we've been having good days lately, but 23 is right out the door with 20. But yeah, going back to if you have an endangered structure, get one light off, get in there and get water on that, cool that siding down, or if you have life safety, you need to rescue someone, that goes first. Remember, life over property.
It's your life or someone else's.
Remember, second and pumper sets water supply. This is a forward lane. You see the other pumpers. The hydrant is probably a decent one. They're using a ground monitor, and if you notice, they have a steamer hydrant with two and a halves on it. Must be a really good hydrant because they have 2 lays off of it, 2 5-inch lays. All right. Should a pumper be at the hydrant? Depends on the situation. Depends on what the hydrant can put out, how far your lay is. Back to 4th of July fire with me, Miller, and Trey. We didn't hit the hydrant with 20. The hydrant was right there. We laid 300 feet. The hydrant supplied itself. Why? Because it's in the city of Festus. And I know city of Festus has big ass mains, and they have water supply that can fight fire. Now, it was our fault that the gate valve wasn't all the way on. It was halfway open. But they had probably 750 gallons a minute with the gate valve being halfway closed. And then, is it uphill or downhill? If it's downhill, you're getting gravity. It's going to help. You're uphill, you may want to put a pumper at it. Or, like I said, 1,000 feet, put a pumper. Reverse lays. What is a reverse lay? It's the exact opposite of a forward lay. Any lay from the pumper or fire to the water supply or hydrant. Big reminder, again, do not forget your hydrant bundle at the attack pump when laying out. Take it off, throw it in the back seat, and then lay out. You may want to know where you want to wrap the hose around. Biggest thing we tell everybody, take the 5-inch, take it all the way up to the front tire, throw it around one of the front tires. Why? Because that gives you an extra 10, 15 feet because the pump's here in the middle, and then you're going all the way up to the front tire. That gives you enough to get off the tire and hook into your intake. When to lay out. You should lay out anytime the first pumper does not lay in. Alright? Again, second pumper can set up. Just remember, again, we'll get there. What I'm going to say, because it's in here. Example 1. Engine 1 proceeds into the scene, advises there's a working fire, and the next pumper in. Come to engine 1 and lay out to the hydrant or water supply. Usually done in cities where multiple units are en route from different locations. In rural areas, the second pumper will either turn around at the fire or back up, then lay out. Usually the second pumper is setting up water supply with 4 tanks, tank relay, or hydrant. This is an example of a reverse lane. So this truck is coming from, we'll just say the east, coming up to the fire truck, laying to the hydrant to the west. Alright? They connect, they should have threw the hose around the back tires and then laid up and hooked it. The thing to remember is all incoming apparatuses need to stage away from the scene. Why? So they do not block the driveways or road, especially on rural roads. You get on Highway P, you only have 2-lane road. And if they all come flying in on you, you're going to have a traffic jam, and then you're going to have to yell at people. Or you come, like the fire we had on Linhart. No, not Linhart. Murphy Road. 3 weeks ago. By the time I could have set water supply, but when we got there, I had a failure on 20, so I had to fix that first. Tank the pump valve broke on 20 and was halfway open. I had to open all the way up manually by going into the pump panel. So if that didn't break, I would have probably had water supply set up properly, but that didn't happen. Port tank operations. What is a port tank? It is a device that looks like a portable swimming pool. Usually folds up and is carried on tankers or tenders. You'll notice that tankers and tenders is always together in this because in the state of Missouri, a tanker is considered a tender. If you go to California and you call for a tanker, you get in a helicopter full of water. Alright, we just call it a tanker because we are used to it. Yes.
It says put on a tanker or pumper.
Oh, see? That's right. Tanker or tender.
Just
You're
so
fine.
you know.
I only had like 2 people review the papers, and one was Chief, and he's got glasses.
Yeah.
So, here you go. Some pumpers may carry them. 6220, the old 6220 used to carry a port tank in the back of it until they got 23. 5824, 5813, them are pumper tankers, and they carry port tanks. Mattville's tanker could be considered a pumper tanker because it has a 750 pump on it, and they carry a port tank, but they consider it a tanker. You got a lot of people making pumper tankers now instead of just tankers. They come in all different sizes. Ours on 23 is a 1,500 gallon and a 2,100 gallon. For example, figure is a, I don't know what I did there. Figure a 1,500 gallon tank and a figure.
I'm confused because that's not on here.
I think you're trying to say figure 15.
There you go, figure 15. Look at that. Is that what it is?
Cause you got
Yeah.
2 pictures right here. On the next page.
Yeah. Yeah, this one's the 15, that was 2100.
Okay. Alright, so yes, we have a 1,500 gallon tank and we have a 2,100 gallon tank. But they come in all different sizes. The thing Chief wants to do, if we replace 23, he wants to upgrade our tanks to 2 3,000 gallon tanks. That's what he wants to do. So these tanks can be connected on the side with a siphon jet. A port tank operations usually occur when there is no hydrant that can be laid from. And this requires tankers or tenders usually a lot. Why a lot? Because you have to keep up with the water being used. If you run out of water on tanker operations, then you have to wait until they show back up to fill. And then the fire attack comes to a screeching halt because you don't have water. Back to when setting up, if you take one tank off of 23 and you take a tank off of 6513, you cannot connect ours with theirs with the siphon jet. You have to do with the ladder and hard suction and siphon jet, which will show on how to set up here in our activity. Setting up tanker or port tank operations. You need to position on the opposite side of the driveway or street from the fill hydrant is on. Everybody understand that. That makes sense.
Mm-hmm.
Why?
So people
Probably
can get in and
tell you
out.
right there. Because you want to, you can use the driveway you're up for tankers to back into or pull into and back up to the tank. If you don't give the tankers anywhere to back up or turn around at, you're gonna have trouble getting them dumped and then off the fill back up. So our rule here is if you're up the driveway, so if we're down here off of Karen and our fill site is at the water tower, the hydrant, the bundle and all that stuff needs to be set up on the west side, the east side of the road. So take 50 feet into the grass, down the road, leave about 25, 30 feet open and set up here. Your hose is gonna run through the grass and out the road. You're gonna have the tanker come in, back up, dump, and then off they go. So you can have a tanker come in, back up the port tank, a next tanker comes in, pulls in, and waits. This tanker drops their load of water, they leave, this truck backs in and then dumps their water. Same thing, it's just a revolving door with everybody. If you are at the dump site for the port tanks, you need to make sure, again, that the driveway or road is open for them to turn around. So when they dump, they can back right up to the tank, and always have a spotter backing up tankers. Alright, it will prevent someone from being ran over. A lot of times firefighters are being killed by being ran over by their own trucks. Alright, that's one of the highest injuries is being hit by their own trucks. If you pay attention to Fire Rescue magazine or Firehouse magazines, they talk about a lot of firefighter got hit by their truck. And killed by the truck because they got hit from being back up. They're walking behind the truck. That's why anytime we back up here, we should have a spotter. Make sure no one walks behind the trucks. It would prevent the driver from backing into the port tank also. And always make contact with the driver through the mirrors and stand to the side. So if this is a truck, I'm not behind the bumper making contact. I'm off to the side making contact with the mirror. If anybody has driven in 23 or been in 23, the mirrors stink and you only have so much room that you can see the people behind you because the port tanks are in the way. So you have to make contact with the driver. Don't start backing him up until he makes contact with you. Either give him a thumbs up, hopefully he gives you thumbs up back. Alright? Make sure they see you first. Again, never position yourself behind the tanker and the port tank. When setting up a port tank operations, you should always throw a tarp on the ground to prevent any road debris from puncturing the underside of the tank. During trainings, we just throw them on the ground. Usually it's here in the firehouse parking lot, because we're always here walking in the parking lot. Usually it's clear when we blow it off. If you're on the scene of a working structure fire or live event, throw your tarps down, then put your tanks on top of it. The tanks are not cheap. Even replacing the tank itself, just the rubber, is not cheap. The bigger the tank is always the draft tank. That makes sense. So if you're using both tanks off 23, the 2100 gallon tank is what you're drafting out of. Remember the laws of water. It's going to equal out. The bigger tank will take more water from the little tank because it needs to equal out. As we learned in Mod 1, again, the characteristics of water, the water will always equal out. The bigger tank will take most of the water. If you're using dual tanks that have side connections like ours, make sure you set the jet siphon before you fill. We've done it when it's full, and it ain't fun because you're going to get wet. During winter time, you're going to get soaked and you're going to freeze. So if you have one tank set up, and you're going to set dual tanks because you need another tank. And the pumper gets down to where he's low enough to put the siphon jet in the side, get it done real quick, and then hook everything up. Then have the tankers dump water. If you don't, you need to do the other way. Let's see if it's on here first. This is just talking about the dual tanks. Make sure you position the tanks correctly because the second tank needs to be drained after you're done with firefighting operations and water supply operations. And if you're on hill and it drains this way and it's going on this way, now we're in a pickle because you can't get water up the hill. So make sure that you drain the tank the proper way. If you're using ours, you can actually just suck it over into the main draft pumper and then have him drain it out one of the discharges. Remember, the pumper can drain the water out of tanks if you can't get the gravity set up right on the road. Like I said, you would have the drafting pumper drain the water for you. If none, if you have no connecting side tanks, so you have ours and Hillsboro's, you have to do the ladder with the jet siphon and hard suction and shoot the water over. Alright, we've done it multiple times. You have different, you get to tie stuff down and all that, which again, our activity we'll set everything up besides put water in it today. You'll know how to hook the hard suction up to the truck with tanks, and then set dual tanks with the side connections and the ladder and the hard suction.
And pray to God we don't get first one.
So, dual tanks and single tank operations. Single tank, the truck's drafted, and they actually have then they have a return hose going along with the hard suction to return water back in. Usually we do that with 2.5 with a gated Y and a hose, and just have someone sit on the hose and then recirculate water if we're not pumping. Dual tanks. If everybody sees this right here, this is one of their siphons. So they got probably a hose connected in here, probably off here, forcing water up and over into the other tank. With ours, we can do the side, which we have that green tube in 23 that goes in the 2 chutes and slides right over, and then you just hook up a 1.5 inch to it and force water right over. So activity 2-2, drop the tank. You'll be wearing firefighting gloves and helmets as a team of 4. So we have we'll do teams of 3 today. You'll set into play a port tank operations. You'll do a single, and then you'll do dual tanks. So you may work together. So one team will set the single, the second team will set the dual, and you both connect in. And then we'll do the side connection with 23, and we will do the over the top of the hard section. Okay, right. So activity 2-2, drop the tank, skill objective, the candidate given proper equipment. We'll probably set up a port tank operations. Skill instructions, you will be wearing firefighter gloves and helmet as teams of 2 to 3. We'll deploy and set up a port tank operations. So we'll split them 2 teams, but we'll work together. It's going to take both teams to do this. You'll deploy a single tank and set up operations, then you will deploy a second tank and demonstrate side connection and over the top. Alright, so go ahead and split up into teams of 3 real fast.
There you go, right there.
Doesn't matter, 3-3. Alright, so we know we're going to do dual tanks, right? So we're doing dual tanks on a fire scene. What tank goes as the drafting tank? The biggest tank, right? Okay. So which one's the biggest tank on 23? Far passenger side one? Alright. So we're going to drop it. So if one team wants to drop the tank and get it going, the other team, if you want to grab a tarp and just throw it out right here in front of the 20 panel. Undone, that one's undone. It might have water back your leg. Sorry. Bring your tank over here and just set it up real fast. here, which way is the right of the parking lot go? It goes this way, right? So we want our opening where? Oh. We want it on that side, right? So get that set up. Tarp guys, you can get your tarp ready because and then you guys will get the hard section. So they'll get the tarp, come back here and get the hard section.
Last time this was pulled out.
Okay. Alright, so you guys go ahead and put that right here real fast. Let's drop that real fast. You need to move the tank out, put the tarp underneath it real fast so tank team. There you go, there you go. Let's go ahead and try and alright, easiest way to do this, okay? You need a team, you need to hit the hard section up. So the easiest thing to do is the guys on the hard section need to communicate with him. They'll get it lined up.
Level?
No. Now let's look at our hard section.
Can you bring the towards us?
So Eric suggested bringing the tank towards you.
We gotta get the parts too. Somebody needs to grab the tank down there.
You just come with the hard section real fast. Just lift it up. So the hard section guy needs to come over here and hold it like this. And then at the tank man can, tank team can move it over. That's it right there. Because what's, are you blocking if you need to get into it? The door. So you want to make sure the door can open and get into it. Okay? We should be good there, but it's just, and then so that goes back in. The only thing you need to do is make sure this is tight. Because this is loose, so you can get your hard section in and then fix this. Toss it right there. Hard section's in. You're ready to draft, ready to dump your water, and then draft. The thing with this is to recirculate water, you have to take a 2.5 or 3 inch run around with a gate valve and a 1.5 inch and hook it into your little drain thing in your compartment to put water back in case you're not pumping and fire, you can keep the trunk from overheating. Single tank, nobody understand? Alright, so dual tanks. This is the fun part. So, the other team that didn't get this tank off, go ahead and get that tank off. You guys are and you get a tarp, and you gotta get the siphon jet.
We got to swing it around. So he's in, so this, Robert here, and he's gonna go that way. When we pull this thing down, we don't have to be in line.
That's, if we're doing the side method, what we need to do with this thing.
Side method, we have some cycles through the middle.
But you gotta get it lined up. So what does this tank need to do?
That tank needs to go that way.
So we need to move the tank out some.
Like,
You can step in the tank. You're not gonna hurt anything.
Now it's not gonna hit the bottom.
That should be good.
make sure that lines up with that. Alright, stop. That opening, that's line up with that. We're gonna have to flip this way.
Alright. So siphon jet. Siphon jet lamp. Lamp. Alright, so this is where, for example, you do not want water in the big tank because you will get soaked. And you will drain your tank if you do it improperly. So the first thing you need to do is hook this up, get both sides undone. So the easiest thing to do with that is come in the opposite way, Robert.
Oh, you know what?
So you can use that rope to pull it through.
Oh, I got you.
Be stuck on. Yeah, it should undo from that. Hide it off. It's not supposed to do that. No, you should be alright as long as you can get it through.
Go to you.
Another person in here to hold the shoot through and try and get the tank open up some.
Let's look at the other first.
Give me
me to pull it backwards? Huh?
No.
Ready?
You need to slide the connection that way.
Yeah, once we get this into there, yeah, we can slide it back.
You need to pull it back?
No, go ahead, push in.
Push.
Okay, now we'll go back.
Not back. Back more?
No, you don't pull that. You're pulling the, this
You
back.
want me to push?
Yeah.
Are we pulling it off? More?
I don't even think the pin was in the car seat. I think he was sitting on it. No, he told it not. Yeah, he was sitting on it. I thought it was just standing there. He checked those seats.
Twist it.
Can you loosen that and then just.
What you need, Robert?
Just help him spin that and get his twist out.
How far are you
It's
through,
closed, it's getting close, I can see it.
The only thing you need to do is have the tube just barely through and you're good to go.
That's probably good.
Too many hands in the pot, somebody's gonna get burned. I'm pretty much,
I think he's got enough. He's just gonna try and get the bigger tank wrapped around the tube real fast. So after it's all the way through,
there you go.
what you want to do is the webbing that Robert's got, you want to tie it off to the tank, because once you start pushing water through the siphon jet with the because if everybody looked into the siphon jet, there's a nozzle inside that jet. All right, you want to tie it off so it cannot be pushed back through by the pressure of the nozzle. What you do is you get a 50-foot section of 1.5 inches. You get the gated Y. You get a 50-foot section of 2.5. 2.5 will get put on the driver's side here. 2.5 will come out and around, put it into the gated Y with the 1.5 and then to the gate or the nozzle here. And say if we had a fire, we did this today. Kobe would be on the gated Y. He would be in charge of opening and closing the gated Y to force water from this tank over here. Because if, remember, back to module 1, the bigger tank is going to take the majority of the water because it's got to level out. The water in here will go through the tube with no problem. But once this tank gets low, this tank will want to flow back and equal out, right? That's where he has to turn on the nozzle and keep the water from coming back over. You're going to keep it over and then you're going to force the water over. Alright, does that make sense to everybody? I mean, if you don't, it's all right, I can explain it. Basically what you're doing is this is a, what is it, 6-inch or 8-inch pipe? Yeah. It can, I think Chief said that it can do roughly 2,000 gallons a minute from this tank over this tank. But I mean, this tank's 1,500 gallons of water, this tank's 2,100 gallons of water. But you can force water over. Go ahead and pause real fast, John. So this is how we set up our port tanks. Now the other way is over the top and over. So what you would need is you'll need we'll take the roof ladder off of, actually we'll take the attic ladder off of 20 with the elevator pizza hard section. And then we need the siphon jet off of 24, the red one in the engineer's compartment.
What about it right there, isn't it?
No, that's the winger. So basically that would do exactly what we're just recirculating water, not through the siphon jet. That just dump the water from the tank, just keep circulation going. Alright, go ahead and open it up there real fast, Jamie.
Yeah, it's attic ladder.
Might want to help get that other hard suction real fast. Yeah, the ladder's out already. Yeah, there's some tools in that hard suction that to remove. Okay. So this is Jeffen's siphon jet, just like that one, but this is a this is just a dry draft siphon jet. So what you'll do is you'll take this. You need to have you would have an inch and a half. All right, just like the concept of hooking into that, but hooking into this. Okay, this would be unscrewed. You would take this and you'll set it up over the ladder. That goes in this water tank. You need to come over here, Shelby. It's gonna go right on top of the ladder.
Oh, fuck. Right, you're in the way, bud.
Yeah, up and over your head. Next time, have it. So that would go all the way down. So you have that set up. Go ahead and pull it back some, Ellen. Where it comes out. I'll just step here and there. Hold on. Alright, so this would come up. Grab that real fast. The ladder can scoot this way more. Okay, go ahead and drop down. You would tie the ladder off with webbing or rope, and then you would tie the hard suction off to the ladder. Again, what you'll do is, that wouldn't be here. This is in case you're using two different tanks, one from us, one from Hillsborough, or whoever. You have to hook your inch and a half in with the gate wide to the truck. When it would be dumped in here, Kobe, being the gated wide man, he would turn it on. He had to lift water up through the hard suction and dump it into this tank. But it's the exact same way as that, but just up and over instead of connecting in. It's the picture of Module 2 when we first started. Did everybody know that how many port tanks were on the ground? That's what they were doing. They were shooting water over to the main draft tank out of the other three. So one would come in this way, one was coming this way, and one was coming over. One draft tank. Now you gotta remember, if you do that, you put water over to the main draft tank out of the other three. So one would come in this way, one was coming this way, and one was coming over. One draft tank. Now you gotta remember, if you do that, you would either have to get a distributor and hook up to all your jet siphons, or have multiple hoses coming off of a truck with a gated wire to run this one, and then run another one. So that's how this setup works. You see this done more often than this because we're the only ones that have this. Nobody else has to do this. But it is faster, but there is perks to this one. There's perks to this one. You need a quick setup for water supply, you're going to go this one. If you're going to be there for a while, this is going to be your way, and you can control the flow of water by dumping in quicker. I mean, now this is a one lane road, so this is the one side of the road, this is the other side of the road, right?
So this is where your shuttle is gonna go.
So if shuttle's gonna go past, what's wrong with this? It's out in the way some, right? So you get to sneak by. Then you have trucks that have side dumps, and you have trucks that have only rear dumps. The rear dump, you either have to go up there and dump in, and the side dumps will come here. Now if you have two water sources, you could hit one over here and one on this side, but you need this side, the side where you turn vehicles around, or trucks around. That's why when you set up using driveways and other roads to get trucks ready to dump. Remember, the time for the relays start when the truck dumps into water, goes, fills, and comes back, and it's ready to dump in a second. Shut the time off. Any questions on setting up port tank operations? Any questions on hitting the hydrant? Everybody understand the water supply? I mean, Kobe, thanks for helping.
Yeah.
I mean, we don't really do a lot of this setup. Usually sometimes we're doing a lot more pumping and spraying water, but
We do, it's just our son, cause that, cause of the
Yeah.
clapper, you know.
I mean, we work with the clapper a lot more than the port tanks because we're still shuttling water. We're using the clapper, tying 3 trucks in instead of drafting out of port tanks. When you set draft operations and you off the main pumper, what's the problem when you have to prime?
Don't think your section is good.
Well, if you're fighting fire and I tell you we're switching over to drafting operations, what did I just do to the
you shut down
interior?
the water
I just
supply.
shut down water supply. For the nozzlemen, they had to start working theirs back out, so all the progress they just made has been just either pushed back because it takes longer than they would have the fire and re-put it back when you just extinguish. So usually it's easier to have a secondary pumper set and draft than some water up. Because then you're not affecting the main pump truck, fire tech truck. And then once you get the water supply established, you can switch over. A lot of times you'll see on our operations, we'll do tankers into the clapper while they're setting this up, and then the secondary pumper will start drafting, and then either if they're close enough, run a secondary 5-inch line to us for one of the inlets, or break down the clapper real fast because we have the tank water that we can just transition over to real fast, and then hook into where the clapper is, and then I would know the difference, but the interior crews would never see the difference in switch up. So this is the basic setup for hematite, port tank operations, and hydrant operations. I mean, like I said, we do port tank, we do the clapper, and we do the hydrant. So there's many tools to our toolbox that we know how to use in the analytic departments. Besides Andrew and Eric and James, the rest of us had been to other departments and they're either what? Daisy chaining or hitting hydrant. And then still daisy chaining. Remember, you put a truck into the line of water supply. So if Miller's pumping, say he's on 24. He's receiving water and pumping water to 20. If you add in 3 more trucks behind him, he's receiving water and pumping water to 20. If you add in 3 more trucks behind him that are daisy chained together, what does the pump operator want to do?
Sure, pumping it to sit right pressure.
Oh, what are they doing to their truck?
Adjust them, and
You're
turn.
constantly just.
They're constantly adjusting, and they want to fill their tank first. They want to make sure they have water. So what's that doing to you? They're taking away the gallons per minute because there's an open hole somewhere and it's filling, so you're taking pressure away. So our golden rule is one pumper receives, so if 24 is getting water and you have 2 other pumpers in front of you and the 20 is the attack pumper, you bypass them a 5-inch and go straight to 20. do not even connect into them. If they say, hey, right here, I'll be like, no. Go into the main pumper. You can fill after we're done. He can backfeed you and fill your tanker after we're done. Because we can always backfeed, just run off discharge, run down to their truck and fill them. Because we still have to drain water off every hose, right? The 24 would have to drain the tanks, send up to the truck, either spray on the fire until it's all gone, or you can backfeed into the other pumpers behind 20 and fill them, so when they leave, they're done. But you really don't want to do that if you're drafting off the lake. Then they gotta go back and drain their tanks and stuff, so just let them sit there and stay out of service. They can always go to the hydrant. If Robert's cleared on 23 and he's doing tanker operations, say, hey, the hydrant's up here, just leave his stuff sitting there until they get done filling, and they can go home and he can swing by and pick everything up, or Chief, or if Miller's in his POV or someone's in POV, they can go swing by and pick everything up. It's just, you gotta know which water supply you guys wanna do. It takes seconds. It's seconds that you gotta think on what you're doing. So, no questions, no comments, no concerns. Alright, we'll break this down, we'll get everything back in, and finish up. You can go ahead and do this. Alright, tanker relays. Tanker relay, or tender relay, 3.6. The tanker relay, what is it? No, it's not a race on a drag strip with tankers.
Haha.
Tanker relay is using tankers / tenders as your water supply. Tanker relay is used for port tank operations and only using tankers and tenders to pump into a pumper via a clapper or some other appliance. Relay operations for port tank operations start when the tanker backs up to drop its first load of water and stops when it gets ready to drop its second load of water. Does everybody understand the time frame on that?
Yes.
Everybody understand what it's talking about? So when the tanker goes to drop its first load of water, that's when the stop watch starts. It will stop when it's getting ready to drop its second load. That gives you an idea of how fast they are going for water. Alright, that's your calculations. On tenders and tankers operations, you use pumping directly into the clapper. Relay starts when the tanker starts to pump into the pumper and ends when getting ready to dump its second load. Almost like the port tank operations, but getting ready to pump into the clapper. Okay, this is how we calculate how fast pumper or tankers are moving. So do we think a bigger tanker is better than a smaller tanker?
Depends.
So, well, yes, it does depend. So, let me see if I can do this right on the board here. So, you have the fire, right here. You have your fill site hydrant, right? Hydrant. Okay, you take 23. We have a 1,600 gallon tank, right? You take 76, 13. They are 3,000 gallons, right? And double the size of 23. Right? Now we say our fill hydrant is roughly 750 gallons per minute. Okay? So you take the time it takes to dump water, to drive to the hydrant, drive back and get ready to dump its load of water. In 23 outrun 7213 or 7613. Probably so. You can do more loads of shuttling than 7613 can do. So yeah, they have more water, but it takes them 3 times longer to get to the fire stand being filled. Because if this is filling 750 gallons a minute, you're filling 23 up in roughly 2 minutes, right? It's about 2.5 minutes. 7613, you have to fill 4 minutes, 5 minutes, and then disconnect and drive back, and then get back in line. So, going along with the paper, a rule for relay operations: if you subtract 10% of the tanker. So if you have a 1,600 gallon tank, you need to take 10% off of the truck. For example, if you have a 1,500 gallon tanker, you need to subtract 10%. You roughly have a 1,300 or 1,350 gallon tanker. The water bottles I gave you guys, pick them up. Take your water bottle and turn them sideways. This is where it comes into baffling and how you set up. So the cap is your dump. All right, we're doing port tank operations, and you're going to dump. If you set the tanks wrong, up gravity, so if it rows like this, and you have your trucks backing up, what are you doing with the tank?
Shuffling the water.
All the water goes forward. Where's the dump? And back. Now if this was full, you're only getting what's higher than the dump. Alright? So if we're downhill, you're going to get usually the full tank of water. So setting up for tanker relays and port tank operations depends on how you set up. Again, 10% of water. What they're talking about is the baffles in there. The baffles, everybody know what baffling is? Or Andrew, you know what baffling is? Kobe? So, DOT, for any tanker carrying any kind of fluid, has to have baffling in it. So inside of the tank, so inside 23, you have walls, plastic walls, that have hose in certain locations. So if a tanker is driving down the road, and you slam on the brakes, it goes like this. So that when you slam on the brakes, that force, that water, is making the truck slide forward. Alright? Now if you have baffling in, so there's different pieces of walls in here that have different angles, so water comes in, runs this way, and around the truck. They don't always run forward and backwards or side to side. It goes through, they have hose up top, hose in bottom, so water can go through. So when you slam on the brakes, that baffle stops water. It's in sections. So you don't have the force of the water to push the truck. Because before, DOT did that, trucks would slam on their brakes and then they would slide, back end would come out, and then they would roll trucks. Baffling is to stop the movement of water because of the force of the water. So you're never going to get all the water out of the truck. So that's why if everybody's taking Chief's pump class, when he tells you it starts trickling out, shut the tanker down and get out. Go fill it. Because if you're just trickling water, you're wasting time on filling the port tank. That's the 10% that you're not going to get. So 20, again, you got 20. It's 1,350 gallons in the tank. Take 10% out. Alright? Does that make sense? Because you're never going to get the full amount of water out of the truck. Depending on how the truck's sitting, the baffling, all kinds of stuff goes in that factor. That's why I had the water bottles. That's the only way I could describe on how the tank and all that is. Water is not always going to come out of the tank, so you don't want to sit there and let the water just drip out. When you know, we drain our tanks when we get into the lake water, so usually, and we flush them. So when we drain the tank, it usually runs out in probably like a little stream. That's when we start flushing the tank with hydrant to get the rest of it out. That's why, because we don't want tank water because of the algae and all that. Also depends on how the truck's parked. Again, if we're uphill and the chute is uphill, you're not going to get all the water out. It's going to be what's higher than the chute. If it's down, you're probably going to get majority. You're going to probably get 90% of that water out of the truck quick. And then you also have the backfill, like I said, and how it's set up. When using tankers or tenders, you need to have multiple fill sites, because if you start stacking trucks up, it's going to take time. Alright, these fill sites are already predetermined locations. I'm working in Rover right now to do the whole district in different sections where you go into, it'll pop up on any location where the truck is, where the pre-populated call, it'll tell you where the tanker fill sites are for that location. So it ain't gonna be like in red, like where it says 28 needs to run EMS calls. It's gonna be clear. It's just gonna pop up saying tanker fill sites, these locations. Because they're predetermined. We already have predetermined locations for tanker sites. Usually built in our water supply fleet plans, and then the C figure for tanker relay, which should be right there. So the trucks are probably off a little bit because 7610 is no longer in service. 7613, and that's 3,000 gallons. But that's the tank equals 10%, 10 minutes, 15 minutes, 20 minutes, 30, 45. How fast you can fill and come back. So it's already predetermined with times. So 1,600 gallons, 10%, 440 or 1440. For 10 minutes, it's going to be 144 on your time. So then the tank sizes. So like if you see 6220 is 1,500 gallons, remember 10% off of it, and then go from there. So this is where activity 2-3, you're going to create your own. We will do this right now. So with the information learned in all modules, it's time to create your own water supply pre-plan. You will be given a copy of residence and location of hydrants or fill sites. You'll have 20 minutes to come up with your own water supply pre-plan. Once done, we will review them in class. Alright, so I have predetermined water supply pre-plans here. Does anybody want a piece of paper to write on? You're probably not going to write on these with your information.
Oh, so you just want us to mentally come up with one?
Just use the back of
He's
this.
gonna give you a
Use
map,
that.
and it shows a house and how would you set your water supply for that
Okay.
structure?
So, Robert, you can have that one. These are all different ones. Ellen, you can have that one. James, you can have that one.
You wanna say what he's asking now?
Not really.
I'll show you in a second.
Because I guess this is the house fire, and then this is my.
Here's that one.
So yeah, okay, on his, yeah, he had, yours is different, but yeah, that's the house, that's my fire. So,
And what you got?
yeah, you got different ones, but yeah.
Is that the house that's on fire? Is it, these are, what's that?
Okay.
Yeah.
It's not-
Don't worry about. So okay,
Okay.
who's got the one that says driveway is 1925 feet long?
Mine.
Okay. Your driveway is from Spruce Road all the way back to this house. That's how long it is. It's 1,925 feet long. Okay? From there to there. Okay? You're going to come up with the idea of what you would do on setting up water supply. Would you lay all 2,000 feet? Would you come in and set up at this house? Or would you use tank relays in and out? Okay, you're gonna do that. The one with the, who's got the one that says driveway is 284 feet. Okay, your driveway is right here. Sorry if you can't see it. This is your driveway.
Right.
From house to Thermopolis Pass is 284 feet. Okay, your hydrant is right here. Okay, and who's got the other one?
1750.
The 1750. Okay, so this is off Highway P. These are actually houses. This is Highway P. This is the driveway of the house. It is
Okay.
1,750 feet from Highway P up the driveway to the house. Okay, if you, the ones that have the hydrant locations, that's where your tanker fill sites are. Okay, so you got 20 minutes. Take your time, don't rush. Come up with some ideas and we'll discuss them after you guys are done.
John,
Yes.
you said that this is 1,000 feet from, or 2,000 feet from here? Or here?
Yes, it's from from this house to the road. So the driveway comes up and goes this way. This is just to take what you guys learned by forward or reverse lay, tanker relays, and port tank operations on how to set things up. You guys can use your phones to look up stuff if you need to use Google Maps or anything. I just want to know how you guys would set water supply.
5324 available in the district, 1432.
Oh, I don't know the chief.
Jeff, 5434, 5427, cash check.
Where do we put our info on the back?
You can write on the back of your packet with your stuff.
St. Clair, 1433.
Hey John,
Yes.
what are the red dots?
What are the red dots on this?
On the yellow lines, that's just where, so I use Google Earth, and that's just where I had to stop and move the line around because it don't go in a straight.
Oh, okay.
It won't follow
I was
you.
like, I'm usually all
The red lines, don't worry about the red lines and the yellow line.
You want us to draw a picture of what we're gonna do?
You can draw a picture, or you can just put what you're going to do.
Okay.
And this is a confirmed working fire?
Yes.
Alright.
I was in this would be smart, I can say that too.
Of course, the city's on the scene, so you know.
How did you find the house?
I just typed in highway P, Hematite, Missouri, and I found it.
5334 available, 1431. Providence Drive, Prospect, Backhill Road, respond on Jeffco 1, 6416 phone for 6436, 5437 Delta, respond for Chesapeake, or 640770 map 20 and 123, 6892 Providence Drive, Cross Street of Scottsdale Road, respond on Jeffco 1, 1436 WTOY 895. pain, does have a cardiac history. She is breathing normally. No aspirin was given since she just returned home from the nursing home and they were unsure on prior treatment.
Do you want like is there supposed to be like a step by step, like pull, crossways?
No, that's how you would
This is
set
water, water supply.
Okay.
It's the water supply itself. So how are you gonna get water to the scene?
That's the only thing you're good. Just like nothing. How would you get water to this thing? Your way may be different than my way, so don't worry about it. We'll just, like I said, we're gonna review them all together, so.
Available in the district, 1438. No code, medical alarm sounding, no contact made. Card 77287, map 378687, Wilbert Lane, Freshman Christie Joe Lane. Respond on check code 1. 5417523, medical alarm, no contact made. Card 77287, map 37 8687, Wilbert Lane, Freshman Christie Joe Lane. Respond on check code 1.
1900 feet.
1440.
250 feet.
5437 on scene.
Not bad. It's an easy setup, easy in, easy out.
That's what I figured too.
Jackson 5402. Yeah, 523 on that Wilbert Lane. 523 respond 1441. Units responding 8687 Wilbert Lane. Alarm company received an activation for a medical alarm in the restroom. No contact made with anyone at the residence. 523. 523, go ahead. Did you receive the information on the NDT? Negative. That's clear.
Yeah, so 6614 in service.
6614 available for 1046. responding 8687 Wilbert Lane. The alarm company just called back requesting to cancel. They made contact with some of the residents, stated that he had placed his device in his suitcase and it activated. No emergency. Your discretion. Okay, 417 available.
Am I done? Alright.
Turn off the roof.
7047, secure now further, 1443.
Good? Everybody done? Alright, so let me move the camera back to face the I don't even know. So pick up the TV here. Oh, let's pick up the TV. Alright, so who had this one right here?
I did.
Okay. So Ellen and Kobe had it?
Yeah.
Okay, Kobe, I'm gonna put you on the spotlight first. What would you do in setting up one spot for this address? You have a confirmed working fire, so 6200 would be on the scene first if it's home. Confirmed working fire, how would you set water supply?
I would lay 2,000 feet of hose to get the water to the house, and then set up a porter tank to fill up just in case I get low on water.
Where would you set the port tank at?
I didn't get that.
No, well, you're laying 2,000 feet, so that means the hose is going to be from Stroop Road to the house.
Okay.
Alright, you could do that with 2 trucks. 20 has 1,500 feet, 24 has 1,200 feet, right?
Yeah.
To make over, we just have enough spare to have enough on both ends. So that's one way you can do it. So port tank would be set up on the outside here,
Yeah.
and then you would run in and then have tankers shuttle in water, right?
Yeah.
Alright. Everybody agree with that? Anybody else besides, we'll let Ellen do hers real fast. So, anybody disagree with laying in? I mean, you could do it. I mean,
So I said reverse light from 62 to 20 because your truck is going to
Okay.
be up at the scene.
so 6220 and proceeded in.
Drop a clapper, connect 23 to 20, and set up porter tank operations at Stroop Road with tanker shuttles to Mappaville Station.
Okay, so are we laying the whole thing with yours, or are we just doing,
Well, 20 is going to be already up at the
yeah, 20 is already up here.
So then 23 is going to come behind it.
Uh-huh.
So you're going to tie in the 23 to 20, and then you're going to have
Port tank operations
porter
all
tank. That's why I was like, I don't
So-
know if I ever thought that or.
No, you could do that.
Okay.
Because, oh, you could do
Because
it.
you're gonna set up, the reason you're gonna set up your porter tank operations out there is because you're gonna have to have a to and from porter tank drop.
Mhm.
So if you set up your porter tanks at the Stroop, your tanker shuttle operations are gonna be able to come in and go out with no problem.
True. There's a lot of ways on this one you can set up. Does anybody else want to put it in? No, you guys can. Everybody can comment on everybody's if you want to do ideas first. And then
Say, why wouldn't you put your tank, grab your tanks up there at the three, that way section,
Right here?
tanks there, so you can go up, back in, and leave.
and then leave.
Yeah.
So that's what the
That's
way
what-
James, he would set port tanks here and lay in to the scene to cut the 1925 off. So he's probably laying roughly 1,500 feet. This would probably be just 1,500 feet. This is probably 400 feet. You'd laying it with 20.
The only problem is how hard would it be to get your,
Right.
oh, you said back your trucks in.
Well,
Makes sense
no,
too,
no. Like what you put your port tanks right there, what he said.
right?
Your first tank roll back in while he's unloading. Your next tanker comes in, goes straight, and parks in that next driveway. And when he's done unloading, the other one pulls up, goes to strip, the other one backs in to the port tank.
so you're saying set tanks up here
Yeah.
on the
Go-
corner.
Yeah, just go back a little
Pump,
bit.
the draft pumper would be here. You pull one truck in, back in, have the next truck come up, and it waits until this truck dumps. Right? Probably a good idea too. Yes.
Question I have though. That makes sense, but if you think about our running cars in that area, your second in truck's gonna be 6713, who doesn't have enough 5 inches supplied to the residents. And your third in truck will probably be 6223. So you got 2 tankers down there at the intersection waiting for somebody to lay line into the scene.
Or well, like she said, your first tanker can go all the way to the scene and tie into 20 already while they're getting the porta tanks and all that stuff.
But then it's gonna be a question, because your tanker might be dumping water when your pumper arrives, then they're having to wait to get there and make a reverse layout.
There's multiple ways you could do this. So here's the
I mean,
way.
your way makes sense too, but
So here's the way that Chief Mike's come up with. Alright, so we have this house right here is 800 feet long, right? This one's 2,000 feet. It's 19 whatever. We just rounded up to 2,000 to make sure we had enough hose. First pumper tank to the scene, rest stage on stroop and set water supply. Okay? What he is doing is if Matt Velveeta's there, they didn't get lost. Not trying to be rude, but there's been multiple times that I have beat them to Stroop Road
Yeah.
with 20. Okay? If 6713 was first in on scene, they have 2,000 gallons of water. They have a pump capable of pumping that 1 or 2 crosslays until 20 gets there, right? Because we don't, Hematite does not use the pumper or the tanker as a tack pumper. So what I would do with going on like this, if I know it's 6713 with Chief is on scene first and he's at working fire, I would bring 20 all the way up, come here, take my 5-inch and wrap it around one of the trees here and lay in. Alright? Going along with how James set up, then you have the first pumper and tanker at the scene. You have 2,000 gallons. You have 1,500 gallons with 20 up there. Their next pumper or tanker could be 23, right? 23 could come in. Now you have to leave the clapper there. And you can actually do 2 ways here. You can bring the next pumper in, which would be 24, or 5710, or whoever pumper's coming in, alright? It's either Festus, 6224, or 5710. Okay? They could come up and set up if they wanted to. If not, you can bring the tankers up, pump in the clapper. You can get one to come in, back in, and one to come in and pull in. Dump your water and send it up, or you can do what Copa did. Lay the whole thing. As long as you got water there and you know you have adequate amount of water,
Right.
you're fine. This one, it gave you a lot of scenarios. Alright, so you can do tanker relays, but up here, it looks like it's all covered in trees. There's nowhere to turn tankers around, right? You could set fill sites right here. You can have tankers running to the hydrants to fill port tanks, and then you can fill 2 tankers running back and forth. You get a lot of stuff with this
They
one.
wouldn't usually run it or fill because it's up the hill or,
What's that?
oh no, that's not.
You're doing, so this one
That's not
only,
gonna matter. Never
this
mind.
one there's no hydrants on Stroop. You're doing tanker relays. Tanker relay is actually going to be a part of this scenario. You have tankers running to Mattville Firehouse or Lee Road and Meyer. That's the two closest fill sites for tankers. If Westinghouse was online, you would go to Westinghouse, but they're offline. Alright, so you're only being supplied by a 4-inch main underneath Joachim Creek from Meyer Road. So that ain't gonna do nothing for you. You need to go all the way back to Lee Road or all the way to Mattville Firehouse. Okay, Mattville Firehouse can do about 1,200 gallons a minute. When I tested it this year, I was blowing their concrete stepping stones into the apron. Actually, I had to shut off the hydrant, and then we had to change the direction of how the water's flowing. I was spraying across Plass Road into the neighbor's yard.
Oops.
So, there's multiple ways you can do this. Now, you know, it's gonna be fast thinking. Heart's gonna be racing. If you have confirmed working fire, what do I do? This is where the driver of the truck has to know what he's doing. Because if he's gonna be there first, if the chief don't get on scene first, and you have a column of smoke, well, there might be burning a pile of brush. 20's gonna go insane. Not gonna do nothing. If you have confirmed working fire, that's gonna be like, okay, hopefully the chief tells you what to do when you come in. 20 lay in from the Y. Okay, I'm gonna land from the Y. Or 20 come all the way up to the scene, next pumper, land. So that's just things you don't wanna do. Because again, I don't see anywhere where tankers can back up into the yard and go out. Because if we did that, and it was raining, well, the trucks are gonna get stuck.
And another thing too would be is if you laid it out on Stroop Road, at the edge of Stroop Road, your tankers, I mean, depending on how many tankers you had, they could go really either way.
Yeah, so the easiest
So
way.
it would be quicker.
So if you laid if you did the 2,000 feet, the easiest thing to do is have the first truck lay in from the Y, lay in, alright? Second truck back all the way up to where the 5-inch was left at, connect onto it and lay the strip. Now, that pumper needs to actually stage right here. Alright? The hard suction needs, or the port tanks need to be set up right in front or on the road. Alright? If you set up here, the port tank can go here, they can come in, back up, they can fill or dump, they can go out and then go up the Mattville Firehouse or go to Lee Road. If, depending on which way you need to, so, again, you had to tell your tankers where to go. If it was 23, I would send them to Mattville Firehouse. If it was 7613, I would send them to Lee Road. You don't want two big tankers going to the exact same hydrant because it's going to take a while. So, any questions, comments, concerns on that one? Alright, well, let's go to the next one. Watch line number 2. Who had highway people? James? Eric? Okay. Eric, how would you set up?
Well, first I saw the pond, so I didn't know if we could draw water out of the pond.
Which pond? Where at?
In the middle.
In the middle, kind of. Because when I zoomed in on the map, it
Right
looked like
there?
it kind of went to the house.
Right there?
Yeah,
Depends if you have access to it. Depends on how much water's in it.
because that's what I was looking at. I couldn't tell if it
Yeah, that's
went
a
to
good
the
idea.
house some more. And then I figured I'd drop quarter tanks at that 90.
Right here?
Yeah, because there's a road that goes back to that barn that's asphalted.
Okay.
And then
have
run
a tanker.
tanker shovels there and have them turn around there.
Sounds fine with me. James, same thing?
Basically what I did. I didn't think about the pond, but yeah, I would set up on the 90 up there, because that does have a road up there.
Hmm?
And then you lay in, there's a road coming right.
Anybody else? Before I show you what Chief come up with? Chief come up with? Anybody? Alright, so.
It was all streets.
Here, that one? Okay. This is the addresses, alright? So, hold on. Let me zoom out fast. Alright, so real quick before I zoom back in. So this is actually a house. It's 4315 State Road P. The driveway is 1,100 feet. Alright, that's from the road to the driveway. This driveway is 1,900 feet. Okay? So, Chief's saying is first pumper and tanker to the scene, rest set up water supply. That's giving them, again, first pumper and tanker scene. Depending on tankers, if 20 is there, 20 should be there first. It's just right out of town. So if everybody, does everybody know where this is?
Is that down further?
This is the winery right here.
Oh, okay. So
Okay,
that's on
that's
this side of West, on that other side of West.
Yeah. No, Westinghouse is way over here. Town of Himmelstadt's right here. Town of Victoria's way over here.
Oh, where's the winery?
Well, if you go down to your 90s and you get to the two driveways, one's paved and one's gravel, take the gravel one up, go up to where it tees off and make the left and go to the winery. Now they have big flags at the end of their driveway. Before they did it, and it's like, she's like, it's still winery. It's like, where's the winery? I didn't know we had one.
No shit.
I've never been up there. But
Now they do. Taking this turn right here, just real quick, it is tight. Okay, this turn, it is tight. It's made for cars, not 20. I took 20 there once before for a brush fire. But anyways, so what he's doing is he wants the first tanker and first pumper to the scene. It could be 20 with 23, or it could be 20 with 5813. Either way, you're getting over 3,000 gallons of water. Again, good answers. You could lay the whole thing if you want to pick 5-inch up. Now, this is all uphill, okay? This is on top of the hill. This is the ridge right here. Does everybody know where the Bradford Farm is? Okay, so you're going past the Bradford Farm, then that's the ridge, all right? So this is uphill. It's all uphill. So you would need a pumper at the bottom. You need a pumper probably in the middle to get all the way up the hill. Easiest thing to do is go with them, have a pumper lay in, and then you set water supply at this driveway. Bring the truck back here where they can pull in, back up. We will replace the driveway if we break it.
All I can say is, can you imagine being the manpower that has to walk up all that?
It's gonna suck.
Woo!
Best way.
It's called Northern California.
How big are those houses?
That house right there is probably, so this is the garage right here. I've been up here for an EMS call. This is the garage and that's the house. So that's probably roughly 3,000 square feet.
You'd need rehab before you got in the fire.
This house right here, I've been to this one too. That's probably about 2,000 square foot house. So, yeah, I would set water supply on the house side, have the first tanker come up, back down, have the second tanker come up, pull into the driveway and sit. When that one's done dumping, you come out, back the next one in. Remember, if you're on the driveways, you have to have a unit down here. The next unit has to wait until that tanker comes out. All right? So if Miller's in 23 and he says 6223, I'm exiting the driveway. He'll come down, the next tanker in line. If it's 7213, 5824, they have to wait until they see 23 leave. Okay? Again, the tanker fill site is either Lee Road at Meyer Road or Highfield Road at roughly the church inside town of Victoria. If you go across the train tracks, make the right like you're in so make the left on Highfield, it's just up around bend. It's right there. Any questions? Comments, concerns? All right. Water supply number 3. This one should be kind of easy. All right. That left 2 remaining. Your driveway is 284 feet. Hydrant's right there. What would you do?
You went first.
Doesn't matter.
I had 6220 lay all the way into the same 5-inch.
Mm-hmm.
I wrapped a tree at the end of the driveway on the right hand side. Then I figured by the time we get up there and get lines off, 23 should be pulling up. And nobody laid in. I left the clapper down there at the tree.
Mm-hmm.
So have them hit the clapper and give me their water. They can exit towards Parthenon and go back towards CC and start water shuttle. My second one pumper, I'm having hit the hydrant, and they're gonna make a reverse leg from the clapper to the hydrant, kicking their hose off to the right side, and then they're gonna feed 6220 from the hydrant. But I want all my tankers to keep doing water shuttle since it's a circle. That way, in case the hydrant went down, I have my secondary source of water set up.
Pretty good. What about you, Andrew?
I just said that I would have 20. I had 23 go with the hydrant, hook up with the hydrant, and then I had 23 go with the hydrant. Sorry, 20 hook up to 23 and 4 lay 5-inch all the way to the fire, and have 23 get that extra pumping pressure. And then if I needed to, you have porta tanks drop at the T if the hydrant went out, so you could do that circle and do the same.
So yeah, that hydrant, if everybody's familiar with the village, this hydrant's down in the hole. So I'll park them on both sides, and then the main comes off of Plato over here. So this Plato right here. Hermopolis Pass goes up to CC, and it's basically the point of the hydrant. There's 4 lines that come in. It's a hot hydrant until you run out of water. Now remember, on this hydrant, it's coming from the water tower at Platten and State Road CC. So that's how far it's coming away. Both ways are good. Thing I would do is, we don't have a supply, and it's because it's just 284 feet and ain't over a long drag. So I would use a hydrant, but I would go with both of you guys and have tankers ready to show them in case the hydrant went down. Anybody else? Anything different? No? Good. That's what I would do. But that's just ideas. So, I mean, there's nothing wrong with it. Every way was good. The long ones are going to be the ones where you have to set up tanker operations and do all your relays. Alright, so let's put this back over here. You can keep them. Alright, so we created our own pre-plans. Number 1 for good. Going on to the conclusion, this will be very small. So water supply operations concluded. Water supply can be small or big. Different types of water supplies can be established. You have connecting to a hydrant, forward, reverse lay, port tank operations, and tanker operations or tanker relays. You can use one method or all methods to extinguish the fire. Water supply needs to be established as soon as possible. Fire departments create water supply pre-plans. And then this is just the conclusion for the whole module 4. For the whole class, remember, going back to module 1, knowing how water works. You need to know how the characteristics of water. It is your main arsenal for firefighting. It has 6 fluid pressure principles. Remember, you have head pressure, static pressure, and residual pressure. You have various devices used are divided up into 2 categories: appliances and tools. Appliances are any hardware that, in conjunction with fire hose, delivers water and water flows through them. Tools are any hardware that are used in conjunction with fire hose, or does not flow through them. Knowing the difference between each appliance will help deliver water correctly to the fire and not interrupt the flow of water. Water supply can be big or small. Different types of water supplies can be established. You have connecting to the fire hydrant, forward and reverse lay again, port tank operations, and or tanker relays. Water supply needs to be established as soon as possible. Remember, we created our own water supply pre-plans here, and you can have one method or multiple methods on extinguishing fires. Thank you for attending the class, and now it's test time.
Get over, James.
Alright, so here's your test. It is
Not good. Not getting you.
let's see.
15.
Take that class. Might have to check what here's that. Just fill in the blanks, circle multiple choice questions, matching questions. After you're done, just let me know and I will take the test from you.
We supposed to put our names on these or no?
The test.
There's no spell on it.
Yeah, this is good. Sorry, that didn't spot there.
My bad.
Unwritten number.
Is everybody done with test?
Yep.
Alrighty, guys. So here is the evaluation course sheet. This will evaluate me and the course. You guys just fill them out. Do not put your name again. That's why you don't put your name. Eric might want to check your paper out. I want to feel a little thick.
There's two of them.
I knew I had stable one with that.
What's the name of the course again?
Basic water supply. You know how to spell the name?
No, I was thinking.
Do you need another location?
Just put Hamilton or Hamilton.
I just put Hamilton Firehouse.
these?
Which one? Yeah. You can keep them.
Don't you need this though?
I don't believe so. I'll have to check.
You're just gonna need this, right?
You guys should be.
We did that.
Let me, while you guys are still doing that, I'll review my thing.
Well, what?
Review my skill packet.
Oh. Oh yeah, it says create your own. So you may need that.
It just says that it's pass or failure if you did it.
But if state asks him for it, he has to be able to. Oh. Story, bro.
I think there's like a couple of the same practice that stapled here. No, they're all stapled together, like in the same.
So this is right here. So.
Oh.
Have none there. Probably just
And there's someone
20,
else.
23. Take that. I'll reschedule it over here. Actually, just so yours, after you're done, just put it on those ones, yours. The only thing it shows is I just had to create a skill sheets and evaluation sheets and test. Doesn't show I have to turn them in. So we'll go.